Welcome to Analyzing and Visualizing Data with Power BI. My name is Pete Benbow, an employee of Davidson College, and I'm your instructor for this course on edX. Microsoft Power BI is one of the leading tools in the world today for working with data. The company Gartner, which is a global technology research firm, has consistently named Power BI as a leading platform in the category of business intelligence and analytics for the past 7 consecutive years, even topping perennial leaders like Tableau. So you've made an excellent choice in signing up for our course, particularly because there's no shortage of jobs for those of us with Power BI skills. This course has been live for over 3 years now, and in that time, I've talked with many former students who were able to use the skills that they learned here to change careers and become full-time data analysts. If that's your goal, I hope I can help you reach it. The main objective of this 4-week course is to teach you the fundamentals of building data sets and reports in Power BI. And this is done by not only providing specific instruction on the various methods and tools that Power BI provides for this, but also by giving you hands-on experience of your own. My overarching philosophy for this, and all the courses I teach, is to learn by doing. So you'll be watching videos, following along with me as we build projects together in Power BI. I want you to leave this course with Power BI projects that you have built yourself, giving yourself a tangible work product that you're proud of and exemplifies the skills that you've learned in our lessons. There's also a verified track available for this course, which gives you access to hours of bonus content, discounts on other edX courses, and provides a certificate from edX upon completion of the course. I also take a very broad-based approach in teaching Power BI, and I avoid focusing too much on any one topic or data set. We will use publicly available sample data sets from a variety of sources, because one of my goals is to give you exposure to different types of data. These data sets were carefully selected for this course due to their potential to illustrate the various concepts and techniques that we will learn, as well as for the interesting stories that they tell. Your experience level and your age do not matter in this course. We've had people take this course who range from teenagers preparing for college to experienced professionals with teenagers of their own. Our lessons are designed for beginners who have never been exposed to Power BI before and are looking to learn. So maybe you're a data analyst just getting started in her career and your manager asked you to take a course on Power BI. Or maybe you're someone who hopes to change careers and pivot into a new line of work. Or maybe you're just a lifelong learner who is fascinated by new tools and technologies. Whatever the case, our course is open to everyone. Of course, some of you might be experienced technologists, seasoned data analysts and software engineers like me who started on a different tool like Tableau and are looking to branch out. Or you're a data warehouse developer who has gotten tired of working on the back end and wants to do more visualization and analysis work on the front end. Experienced developers and engineers might have heard some of this content before, but as long as you're new to Power BI, I guarantee there is more than enough learning here to keep you engaged. First of all, this course is entirely self-paced, which allows you to pause, rewind, and review the videos as needed, and which gives you the freedom to complete lessons on your own time. We do it this way for a few reasons, not least of which being the fact that we have a lot of international learners for whom English may not be their native language, and we want to accommodate those people. Some lessons will include reading assignments that reinforce the lessons from the videos, and most of these lessons have required comprehension questions at the end of them that will test what you learned from the videos and articles. The primary tool that we will use is Power BI Desktop. The Power BI ecosystem is huge, with applications in the cloud, a mobile app, and a report server for on-premises hosting options. But Power BI Desktop is the main application for creating datasets and reports. By focusing on desktop, we can have more time to complete practical exercises with sample datasets, reinforce these lessons multiple times so that you can recall them easily, and teach best practices. Now, Power BI Desktop is a Windows application, but we'll discuss in another video how Mac users can also participate in this course. In week 1, we'll start at the very beginning with an overview of core concepts that are relevant to Power BI, including some discussion of how the technology works. Then we'll install Power BI Desktop, import our first dataset, and begin learning the basics of report creation in Power BI. I want you to finish week 1 by building your first Power BI report because I want you to get that sense of accomplishment early on and use that to fuel some excitement for the rest of the course. In week 2, we'll build upon that foundation using new data sets. We'll reinforce the lessons from week 1. We'll begin learning additional tools and techniques to enhance your Power BI projects as well. And this will be accompanied by a deeper dive into data preparation while also learning more data visualization techniques. In week 3, we'll get into more complex topics around different types of data sources and how to model your Power BI solutions in those situations. We'll also look at more ways to use Power BI to create an app-like experience for your end users. Now, at the end of weeks 1, 2, and 3, you will receive a final exercise that you will complete on your own with no guidance from me. This final exercise will usually involve downloading a sample dataset and working through a set of problems, then answering another set of comprehension questions that will test whether you were able to execute the exercise successfully. At the end of each final exercise, we will include a video where I walk you through how I would have completed it so you can compare your results to mine. Finally, in week 4, we'll briefly go into some important topics in the world of report design, such as how to use empathy and visual hierarchy to craft meaningful reports for your audience. We'll also talk a bit about the Power BI service, which is Power BI's home in the cloud, where you can publish and share Power BI reports with others. And lastly, you'll tackle a capstone project that asks each of you to independently build a final Power BI project from scratch based on a sample data set and using the skills that you've learned throughout all these lessons. At the end, your knowledge will be tested with a final exam to complete the course. This will be accompanied by some videos about additional resources that you can use to continue your learning beyond this course. Since we first launched this course in 2020, I've connected with students from all over the globe, from Seattle to Singapore, from Mumbai to Madrid, and people who have taken this course have ranged from college students and staff right here at Davidson to supply chain analysts in Vietnam and finance professionals in Dublin and beyond. And so although Davidson is an American college and this course is taught in English, I have been amazed by how many students we've attracted from outside the United States, and I've been overwhelmed by the positive feedback that they've given. I'm very grateful to have you all here as we launch the newest edition of our course, Analyzing and Visualizing Data with Power BI. Let me take a moment to tell you a bit more about myself. As I mentioned, my name is Pete Benbow, and I work at Davidson College, a small liberal arts school located just north of Charlotte, North Carolina, in the southeastern United States. I've been working at Davidson for over 6 years as a business intelligence developer and data architect. That means I spend most of my time administering the college's Power BI environment, as well as building data warehouses in Microsoft SQL Server and managing numerous other parts of our data platform, such as developing data integrations and reports. Outside of my regular day job at Davidson, I also teach this course and an introductory course on SQL databases, which you can also find right here on edX. Prior to Davidson, I worked as Director of Research and Analytics at a legal services company here in the United States, where I managed a team of analysts and data scientists. I've been working in the Microsoft Data Platform for over 10 years, starting out first in Excel and SQL Server reporting services, and more recently with Power BI. I'm a Microsoft certified trainer, and I hold multiple certifications in Power BI and Azure, which is Microsoft's cloud platform. I'm teaching this course because I believe strongly that everyone benefits from having strong data skills in the 21st century. It doesn't matter what your background is. For instance, I didn't start my career as a BI developer, and I don't have a degree in computer science or data science. My academic background is actually in political science, which I studied right here at Davidson. When I was in school, I didn't write code, I wrote research papers. I even studied political philosophy through a summer program at Cambridge University in the UK, and I didn't imagine back then that I would ever work in data like I do today. In fact, I think I used to think of spreadsheets and data as incredibly boring compared to analyzing the works of Plato and Hobbes. And I'm being totally sincere when I say that. But somewhere along the line in my career, I found myself working a job where I could make a huge impact by learning some data skills and applying them to some problems that our business had. I learned about the art of storytelling with data and how to use elements of graphic design and human psychology to make data more impactful, and that really appealed to my background in the humanities. I learned that a background in political science and philosophy in many cases made me a better technologist because those subjects had made me more attuned to the human elements of how we work with and interpret data. After all, it was Steve Jobs himself, the chairman, CEO, and co-founder of Apple, who once told us that technology alone is not enough. It's technology married with the liberal arts, married with the humanities, that yields us the results that make our heart sing. And those revelations completely changed the trajectory of my career. I've been working with data ever since. So if you're coming into this course with no previous experience and you don't have a degree in computer science or information systems, don't worry about it. Your background does not matter. If you don't want to be a full-time software engineer but rather just a hobbyist, that's fine too. We don't assume anything about who you are in this course or your level of experience. Thanks to tools like Power BI, it's easier than ever to learn data skills and apply them at work or at home, whether you're still in school, just starting your career, or you're an experienced professional. Okay, that's enough about me. I'm really excited and fortunate to be here today teaching you this course for edX on behalf of Davidson College, and I hope that you're ready to build some cool stuff with Power BI. In this video, I'm excited to share more about our verified track content. With the verified track, you'll gain access to multiple hours of exclusive content showcasing additional tips and tricks for working with Power BI, and you'll be able to watch in-depth interviews with Power BI experts from across the world. These discussions with well-known leaders in the Power BI community will open up exciting new avenues of learning for you. You'll also receive a discount from my other edX courses like Introduction to SQL, which teaches you the basics of working with relational databases and a variety of methods for using SQL or SQL to analyze and manipulate data in a database. It includes sample databases you can work with, similar to the sample datasets in this course. And you can use Power BI to connect to those sample databases and continue your learning beyond this course. Learners on the verified track will also have an opportunity to amplify their portfolio of work via our network. In week 4, when you complete the capstone project, you can opt in to our contest. We'll review the submissions from our verified track learners regularly and identify the top submissions and share the contest winners on our social media channels from time to time, which will earn you some recognition for your work and skills to leverage professionally. Additionally, free audit learners will have only 4 weeks to complete the course, but if you join the verified track, there is no time limit to complete the course, and you'll continue to have access to additional videos and course materials for as long as you desire. Upon completing the course, you'll also receive the official course certificate from edX. So, if you're interested in receiving this valuable bonus content and earning a certificate from edX, you can join us on the verified track. Thanks. Power BI gets new functionality from Microsoft all the time. Almost every month of the year, they are releasing new features and resolving any issues. This is incredibly exciting for me as an experienced Power BI practitioner because I get to play with Power BI almost every day in my career, and it's great to see all the new toys that Microsoft keeps giving us. And it should be exciting for you, the students of this course, as you realize that there is so much to learn about Power BI and its capabilities. However, all these new features are a bit of a double-edged sword because it can be very hard to keep up with the pace of innovation that is being set by the Power BI team at Microsoft. We can't always keep the content of this course up to date with the latest and greatest features that Microsoft is giving us. If you find that any of our course content is out of date and no longer reflects the look and feel of the latest version of Power BI Desktop or PowerQuery, I invite you to submit that feedback to our team using the instructions below so we can make the necessary improvements. Anyone who knows me personally knows that I am a relentless perfectionist, and Davidson and I want to make sure that we deliver the best learning experience we can. Thanks, and I hope you enjoy the course. Welcome to week 1 of our course on Power BI. Week 1 is designed to familiarize you with some of the core concepts of Power BI, as well as the specific tools that we'll be using throughout this course, namely Power BI Desktop and PowerQuery. PowerQuery is an application that comes bundled with Power BI Desktop, and it's what we use to connect to data sources and prepare the data before we load it into Power BI Desktop. Once the data is loaded in Desktop, we can model and visualize the data to create an interactive report. And that's primarily what we're going to cover this week. We're going to install Power BI Desktop, orient you to both it and the PowerQuery editor, and then we're going to build our first fully functional Power BI report. We'll start with some data related to US states. I chose this particular data set because of its simplicity for beginners, but also because it will allow us to bolt on some additional data so we can demonstrate some rudimentary data preparation and modeling techniques later in the week. Specifically, we'll begin with basic information about the states themselves, and then we'll layer in some additional data about their gross domestic product, or GDP, as well as their population. To make this even more interesting, we'll look at these attributes over a number of years so we can look at some basic ways to filter and examine trends over time. Our Week 1 data comes to us from the U.S. Bureau of Labor Statistics, a great source of data for those who are interested in analyzing U.S. economic figures. After that, you'll receive a final exercise for the week to complete on your own, which will use the same data and report that we've been working on, but you'll add some more calculations and use those to answer some quiz questions about the data. All of this builds a foundation for the lessons that follow in weeks 2, 3, and 4. So, without further ado, let's get started. Before we begin working with Power BI itself, let's take some time to explore how development in Power BI generally works and the various components that are involved in Power BI. This is a long lesson and fairly complex, so pay attention to the terminology I'm using and the diagrams and animations, take some notes, and pause and rewind the lesson if you need to. However, don't get frustrated if you don't immediately grasp everything in this lesson. I'm going to reinforce these concepts at various points throughout the course, which will hopefully illustrate them to you in a more relevant way. Let's start this discussion with some high-level terminology. If you're wondering what the BI and Power BI stands for, you're probably not alone. It stands for Business Intelligence, which refers to the methods and software used by people and organizations to analyze data for the purpose of deriving actionable insights. This is a very broad definition, you'll notice, because the truth is that BI systems at different organizations can look radically different. Not everybody uses Power BI for their business intelligence needs. Some companies use other platforms like Tableau, Click, and Google's Looker platform, to name just a few, and these platforms all have similar capabilities to Power BI. And how an organization uses business intelligence tools depends greatly on the organization itself. For example, if you work for a manufacturer, your BI portfolio might be focused largely on supply chain reporting that gives you an idea of how long it takes raw materials to arrive from your suppliers to your manufacturing centers, and then how long it takes for the manufactured items to get to their distribution centers to be sold. The purpose of these reports might be to identify bottlenecks in the supply chain so you can try to alleviate those issues while also managing your customers' expectations. If you work for a software company, those reports might be focused more on software sales. How many licenses did you sell this year compared to last year? How are your salespeople performing relative to their sales targets? And what are your profit margins? These might help the executives at your company decide how to adjust the prices of the software licenses or what sales incentives they can add to boost sales performance. Or maybe you work for a public health organization and you need to build a dashboard that measures healthcare outcomes across a wide geographic area, such as infection rates or vaccination rates, so that your doctors and nurses can be strategically deployed to those locations that are underserved and might benefit from having more providers to give care. Business intelligence platforms like Power BI are designed to build solutions for all of these scenarios and more. But the main principle is the same. The reports and dashboards that we design in our BI tools are using data to create actionable insights so that people know what decisions they need to make. This is often known as data-driven decision-making, and it is, in many cases, the end goal of developing BI solutions. Now, when I say development or developing, I'm referring to the process of building a business intelligence solution in Power BI. And when I say solution, I'm talking about a Power BI project that meets a specific purpose, like one of the examples we just talked about. Regardless of the specific solution that we're developing, most business intelligence solutions involve the following key components: a data source, a data set, and a report. Let's talk about each of these components, starting with the data source. This could be a file, like the CSV files that we're going to primarily use in this course. This could be a database that is hosted on a server, either in the cloud or perhaps in a data center in the building where you work, or a database that is installed on your laptop or desktop computer. Or the data source could be a table on a website. There are many different potential sources of data depending on your organization, and you may need to gather data from just one source, or you may need to combine data from multiple sources for your project. The next component is the data set. To me, the data set is the beating heart of every Power BI solution. It is the focal point, the most important component. We will spend a lot of time in this course talking about Power BI datasets, so it's important to define the purpose of datasets in Power BI and how exactly they work. This is going to be the main goal of this video because it is foundational to everything that we will talk about in this course. Think of the dataset as a prepared subset of data from your data source that is designed to meet a specific business purpose. Data is extracted from the data source and loaded into the dataset so it can be used for analysis. The final component is the report. In Power BI, the report is connected to the dataset and gets all of its data from there. The report consists of pages, and it must have at least one page in it. Users can then navigate between pages and interact with all of the visuals in the report, which are built using the data in the underlying dataset. So, viewing this at a high level, the dataset acts as a sort of intermediary between the data source and the report. It's a staging ground for that specific subset of data that we need for our BI project. Now, the process of getting data from the data source into the dataset is known as extract, transform, and load, or ETL for short. We're extracting data from the source, transforming it in some way, maybe big transformations, maybe only small ones, and then we load it into a data model. This ETL process generates our Power BI dataset, which can then be used by our report. These transformations could consist of small operations like cleaning up dirty data and adding some calculations to a single table, or they could consist of large operations like fundamentally restructuring the data and merging two tables together from different sources. The output of all of these transformations is then loaded into a data model, which creates the data set, and that data set is what feeds your report. I'll address the distinction between data models and data sets later in this video, but for now just know that data sets must consist of at least one table of data, but they can consist of dozens if not hundreds of tables. Our primary goal with the data set is to build a logical set of tables that are loaded with data, and they feed that data to our report so it can be visualized and analyzed. When all of these components are put together in Power BI Desktop, they can be saved as a PBIX file or PBIX file. This stands for Power BI Exchange, which is the most common file format used in Power BI. Remember that PBIX term because we'll come back to that soon. Now, I like to describe Power BI development generally by saying that it consists of about 75% data preparation and modeling and only about 25% data visualization. That means that most of the work that happens in Power BI is around building that data set. The report, with all of its cool charts and visualizations, may be the only part of this process that your users get to see and interact with, but it typically represents the smallest part of the overall picture. So let's put this into a cooking analogy to make it easier to understand. Our goal is to bake a cake. To accomplish this goal, we need the necessary ingredients: eggs, flour, sugar, butter, milk, etc. The sources for these ingredients are our refrigerator and our pantry. Our pantry has a lot of other items in it like rice, oats, potato chips, canned beans and vegetables, bottles of red wine, etc., but we only need to get the ingredients for our cake. We'll leave that other stuff behind. And in the refrigerator, we've got some meat, perishable fruits and vegetables, leftovers from last night's dinner, and some bottles of beer, but we only need the eggs, butter, and milk. So we're only getting a subset of what we have available, only what we need to bake a cake. From a Power BI perspective, the pantry and the refrigerator are two data sources for our solution. We need access to both of them, but we only need to retrieve some of the items that are stored in them. So we'll get the subset of data that we need to begin building our solution. Back to the kitchen, we need to start transforming our ingredients into the form needed to create a cake. We can't just throw everything into a bowl as it currently exists and then stick it all in the oven. If we do that, all we'll get at the end will be a mess that isn't fit for human consumption. We need to follow a recipe which lays out the steps that we need to take to prepare our ingredients. We need to soften the butter, crack the eggs, sprinkle in some other ingredients like chocolate chips and spices, and carefully mix it all together until it has the right consistency. Also, we're not going to dump all 12 eggs into our cake, and we're not going to add 5 pounds of sugar to it, no matter how delicious that sounds. We need to measure out the right portions of each ingredient. Ultimately, if we follow the recipe, that will produce the cake batter, which we can then pour into cake pans, and then we can bake them in the oven. Translating this back into Power BI, we're talking about data preparation and modeling at this point. We're only getting the data we need, and we're transforming that data to make it ready for reporting. Filtering our rows and removing unnecessary columns is like getting the right measurements of our various ingredients. Combining data from different tables and different data sources is like mixing the ingredients together. We're creating a structure for our final product. At last, when the cake comes out of the oven, we have our data set. We still have some work to do in terms of maybe putting icing on it, but largely the work has been done. We've taken our ingredients, run them through a recipe, and built our final product. Now, this is probably the weakest part of the analogy, but this is the point when our friends can have a slice of our cake by building reports on top of the data set. They get to consume all of our hard work, but they probably weren't there with you in the kitchen when you were doing all of that work needed to bake the cake. So that's what I mean when I talk about Power BI development being 75% data preparation and modeling, but only about 25% data visualization. There's usually a lot of work that needs to go into Power BI before you can arrive at the satisfaction of that final shiny report that you can hand to your users. So the pantry and refrigerator are our data sources. We bring the ingredients from our data sources into our kitchen, where we prepare our data set. In this analogy, the kitchen is PowerQuery. As I mentioned in an earlier video, PowerQuery is bundled into the Power BI desktop application. It's also a fundamental part of Power BI in the cloud, as well as other parts of Microsoft's data platform, including tools that you may have heard of like Power Apps and Azure Data Factory. And it's even bundled with Microsoft Excel for Windows, which means the techniques that you learn in this course to work with PowerQuery can also be applied inside of Microsoft Excel. PowerQuery has all of the tools we need to follow our data recipe. It has the measuring cups, the mixing bowls, the blender and spatulas, literally everything that you need to filter the data, combine it, and supplement it. PowerQuery connects to our data sources, retrieves data from them, and then allows us to transform that data and load it into our final data model. The language behind PowerQuery is known as PowerQuery M, or just M for short. Microsoft describes M as a formula language, but I really wish they called it a recipe language so it would fit this never-ending analogy that I'm using here. Either way, when you're using PowerQuery Editor and Power BI to connect to data and make transformations to it, it's actually generating sequential formulas in the M language. This code is even visible inside the PowerQuery Editor using the Advanced Editing option, as you can see here. The first step in the sequence is connecting to the data source. The second step might be selecting the table that you want to query from the data source. The third and fourth steps might be filtering out the rows and columns you don't need. And then the final step might be renaming your remaining columns so they make more sense to your users, because a lot of databases can have unusual naming conventions that make literally zero sense to most people. In this course, we will use the formula bar in PowerQuery to make small tweaks to the M code, but you will not be expected to write complete queries from scratch. Some people have that ability, but they tend to be very advanced users of PowerQuery in Excel and Power BI, and I don't expect beginning learners to acquire that skill just yet. I'm only showing you the code so you can get an idea of what the formula language looks like, but I will give you links to Microsoft's PowerQuery documentation so you have a resource to continue your learning after this course. So that's an example of a basic query in PowerQuery, and the beautiful thing about PowerQuery is you can visually see that sequence in the editor as you're processing your data through these various steps and transformations. That's the biggest reason why I use this cooking analogy whenever I teach Power BI, because I always refer to this sequence as the recipe. We'll talk more about this in our upcoming lessons. The software that enables PowerQuery to do all of this connecting and transforming is called the PowerQuery Mashup Engine, and it literally is the engine behind PowerQuery. When working with Power BI Desktop, the PowerQuery Mashup Engine is a runtime environment that can actually execute your PowerQuery M code using your computer's internet connection, processing power, and memory to connect to various data sources, perform the ETL operations we just described, and build your dataset. When your Power BI solutions are deployed to the Power BI cloud, the Mashup engine performs the same operations there, but using Microsoft's network, processing power, and memory in the cloud. So you can see that PowerQuery and its Mashup engine are woven into the very DNA of Power BI development, which means it's critical when learning Power BI to understand how PowerQuery works. To begin our course, let's download and install Power BI Desktop. In Windows, open your web browser and use the address bar to navigate to aka.ms/PBI single installer. This will take you to the Download Center for the latest version of Power BI Desktop. You can confirm which version of Power BI Desktop you're downloading by opening the Details header below the Download button, where you can see the version number and the date published. Clicking the Download button will display two options, PBI Desktop Setup x64 and PBI Desktop Setup. Which option you need to download depends on your Windows operating system. To confirm which version of Windows you're running, use the Windows Start menu to search for About Your PC. At the top of this window, under the heading System Type, you'll see either 64-bit operating system or 32-bit operating system. If you're using 64-bit Windows like I am, you should download the Power BI Desktop installer that has the x64 suffix at the end of its name. Otherwise, if you're using 32-bit Windows, you should choose the other version that doesn't have the suffix. Then hit Next to begin the download, and this download will take a few moments. Once the installer is downloaded, run it from your browser or from your Windows File Explorer. Select your language, then click Next. And from here on, just choose the default options. Accept the license agreement, and you can choose to include a desktop shortcut or not. Then hit the Install button. This will take a few minutes to complete. While it's installing, let's go over some other things that are outlined on Microsoft's official documentation site about installing Power BI Desktop. You can find the link to this site in the area below our video. First, there are two methods to installing Power BI Desktop. The first method, the one I just walked you through, is the direct download option. I prefer this method because, well, it's how I've always done it. However, you can also download Power BI Desktop from the Microsoft Store on Windows by just opening the store and searching for Power BI Desktop. And it really doesn't matter which method you choose, honestly. Second, let's talk system requirements. At the top of this page, you'll find a heading called Minimum Requirements. Microsoft outlines the minimum hardware and software requirements for Power BI Desktop on this page. and most of these should be fine and you shouldn't give them a second thought. Notice, however, that you will need a widescreen monitor with a 16:9 aspect ratio. And with regards to memory, Microsoft recommends 4 GB, but I actually think 8 GB is what you need for a mostly painless Power BI experience. Depending on the amount of data you're working with and the calculations your system needs to do through data transformations and such, 8 GB is a great start. Honestly though, I've found the experience typically optimizes around 16 GB of memory. The computer I use for this course is actually running with 32 GB of RAM, which makes for an outstanding experience in Power BI Desktop, but I know that not everyone is going to have that kind of hardware. So just know that you can get away with 4 or even 2 GB according to Microsoft, but you should hopefully have at least 8 GB, which is pretty standard these days in 2023. Now, let's return to our installer where we can see Power BI Desktop has finished installing. Let's choose to launch Microsoft Power BI Desktop from here and click the Finish button to close the installer and open the application for the first time. And there you have it. You've installed Power BI Desktop and are now ready to begin this course. In the next video, we'll get oriented to our learning environment and we'll start bringing in some data. When we first open Power BI Desktop, we're met with a welcome screen. It contains many helpful links for getting started with Power BI Desktop, including videos, sample data, and a connection to the Power BI blog from Microsoft. On the left-hand side of the screen, we have quick actions that allow us to go straight into getting data from a data source, or we can connect to recently used sources, open recently opened reports, or we can use the Open Other Reports button to browse our computer for other reports that might be on our hard drive that we want to look at. To close this screen, I'm going to click the X in the upper right corner so we can begin our orientation. What you see in front of you is Power BI Desktop in all of its glory. Your attention is immediately drawn to the center of the screen where it prompts you to add data to your report through a few options, or by getting data from another source. Before we get into that though, let's take a few moments to look around the application and learn where things are located. Power BI Desktop is broken down into 3 main views: the report view, the data view, and the model view. All of these can be accessed using the 3 buttons along the left-hand side of the application. The report view is where we go to add visuals and build a coherent report for our audience. But we don't have any data yet, so there's nothing for us to build. The area of the report view that is bounded by dotted lines is known as the report canvas, which is the area in which you can add your visuals and other content. The size of the canvas can be customized to suit your needs, but it defaults to a widescreen format to suit most modern computer displays, and it's set to a standard 16:9 aspect ratio. Everything beyond the dotted lines is known as the wallpaper, which can be configured separately from the canvas to give it a different color or a background image. Other than that, there isn't much you can do with the wallpaper. It's primarily just a style element for the report. Now, the data view allows you to browse all of the tables in your data model and see the data that has been populated in them. This is helpful when you want to see what is actually in your data set. You can sort and filter the data like you would in Microsoft Excel, or you can create calculated columns and measures. The model view also allows you to view the tables in your data model, but instead of seeing the data you've populated in the data set, you will be treated to a diagram that gives you sort of a top-down view of the tables, what columns they contain, and how these tables relate to each other. The model view is great for creating and maintaining relationships between tables, as well as configuring the columns themselves to change how they are formatted or to add documentation to them. Moving to the right-hand side of Power BI Desktop, you'll see that there are expandable and collapsible panels on each of the 3 views we just looked at. On the model view, there's a data panel that will show you all of the tables and columns and measures in your final data set. There's also a properties panel that allows you to change the properties of the objects in your data model. That data panel carries over to both the data view and the report view. It's visible in all 3 views. You can also see the Visualizations panel here on the Report view, which is an older interface for Power BI Desktop. When the newer interface is enabled, the Visualizations panel is actually removed and its features are incorporated into other parts of the application. If you're already working with the newer interface, you don't need to worry about any of this. And if you still have the older interface of Desktop, don't worry because I'll show you how to switch to the newer one in our next video. In the Report view, you can also see a Filters panel. This is part of the report itself, meaning that you can use the Filter panel to control what data from your dataset is shown in your report pages. We'll talk more about the Filters panel in a later video. For now, you can just click to make it collapse. Finally, along the top of our application is the ribbon, which is also expandable and collapsible. The ribbon defaults to the Home tab, which gives you options for getting and transforming data, adding new content to your dataset, and publishing the report. The Insert tab gives you more options for inserting content, including static elements like shapes, and some visuals that are driven by artificial intelligence features that are built into Power BI Desktop. The Modeling tab gives us tools to add measures and calculated columns to our data model, as well as add parameters and manage security features on our dataset. The View tab allows you to customize your report's color scheme and other thematic elements, turn on different panels in your report view, and even switch to the Mobile Layout Editor for designing mobile reports. The Optimize tab gives you some great tools to monitor and improve the performance of your Power BI report, which we'll cover in more detail later in this course. Finally, the Help tab gives you a bunch of resources you can use to improve your Power BI skills. First, the About button will show you what version of Power BI Desktop you're using, as well as copy diagnostic information, which can be very useful if you need to report an issue to Microsoft. On the rest of the Help tab, Microsoft has provided several links to training videos, documentation, support, and other resources that are always helpful to Power BI developers. Also, make note of the page controls for the report canvas in the bottom left corner of the application, and the zoom controls in the bottom right corner. Along the very top of our application, moving from left to right, we have buttons to save our report, as well as to undo and redo our most recent actions. And finally, at the very top center edge of the application, we find a search bar, which is enormously helpful when you're not sure where to find something in Power BI. Just click into here and begin a keyword search. For instance, I'll search for parameter, which returns a pair of options for adding new parameters to my report. If you're ever lost, using the search bar is an excellent way to take yourself directly to the feature you need and get yourself back on track. Okay, that's the basic layout of Power BI Desktop. In our next video, I'll walk you through a few options and settings in Power BI Desktop, and then we'll get started with building our first report. Before we start on our first report, let's review the options and settings in Power BI Desktop to see how you can configure the way your learning environment operates. To begin, open the File menu on our ribbon. This will open a menu on the left-hand side of the screen that displays options for opening, saving, and publishing your reports. The main thing I want to focus on, though, is the Options and Settings menu towards the bottom. Clicking this will open another small panel where we can choose between Options and Data Source Settings. Click on Options, and this will open a modal dialog or pop-up window with numerous pages arrayed along the left-hand side. Global settings are used to control how all of your Power BI Desktop projects are configured. This means any new or existing Power BI project that is opened will conform to these settings. Meanwhile, the current file settings can only control the Power BI project you are currently working on. Obviously, this allows you to control certain features of the report you're in without overriding the global settings that affect all of your projects. I won't take you through all of these pages, but there's some really cool stuff in here. For example, if you're a data science professional who knows how to code in languages like R and Python, you probably saw the options for R scripting and Python scripting and started drooling straight away. We'll cover those features in the verified content for this course, but we won't go into them here. I'll just highlight a few things. Let's start on the Data Load tab, which allows us to tweak some settings that can streamline the data load process between PowerQuery and Power BI Desktop. You'll also see there's a section on data cache management options. Query results in Power BI Desktop are cached by default on your computer, which allows your development process to go a little faster when you're working in desktop. You can clear the cache if you need to free up some space on your hard disk. And you can set the maximum allowable hard disk space the cache can take up. Mine is set to 4096 megabytes, which is 4 gigabytes total. The main option I want you to notice here is the Time Intelligence option, which says Auto Date Time for new files. I want you to disable this option under the global settings before we begin our course. I'm going to explain why we disable this option in a later video when we begin working with data that contains dates. This option helps us streamline our data model and optimize its performance in those situations. Next, let's take a look at regional settings. Because this course attracts students from all over the world, I want to take a moment to show you how to configure the language settings in Power BI Desktop. The application defaults to using whatever language is your default language in Microsoft Windows. However, if your Windows installation is in English, like mine is, and you would like to switch over to another language like Hindi, I'll show you how to do that. Simply open the drop-down menu under Application Language, select the language you want to switch to, and then click OK. At this point, you'll be prompted to exit and restart Power BI Desktop, so let's go ahead and do that. And when Desktop reopens, you can see everything is now in Hindi. If I want to switch back to English, I just need to retrace my steps. Go to File, go to Options, find the Regional Settings, and change the language back to the Windows default. Click OK, and then restart Power BI Desktop one more time. And now we're back in English. So next, let's take a look at preview features. I'm going to go back to File, Options, and the Preview Features page. Microsoft is always debuting new features in Power BI, and one of the ways they gather diagnostic data and user feedback about these new features is they release them in preview periods. There are typically two main preview periods. Private preview, where certain users are invited to test new features for Microsoft in a contained setting, and public preview, where these new features are released to all Power BI users. After a feature's public preview period is over, it typically becomes generally available, or GA for short, which means it becomes a standard feature in Power BI. Because we are using a publicly available version of Power BI Desktop, all of the features that you see here in this list are public preview features that we can enable or disable inside Power BI Desktop. So remember in our last video how I mentioned that the report view interface changed in 2023? Well, this is where you can enable that new interface if it wasn't enabled when you first opened Power BI Desktop. Just go to the option named On Object Interaction and click the checkbox next to it to turn it on. This will enable that feature the next time we restart Power BI Desktop. While we're on this section, let's also enable the following features if they aren't already enabled: the Shape Map Visual, Modern Visual Tooltips, Spark Lines, Field Parameters, Enhanced Row-Level Security Editor, and Dynamic Format String for Measures. If these features are not visible under Preview Features in your desktop options, that means either you have a newer version of Power BI Desktop where these features are already generally available, or you have an older version of Power BI Desktop that does not yet support these features, in which case you need to download and install the latest version. One last thing before we leave options. Go to the Report Settings page under Global Options and turn on the Display Smart Guides when visuals are aligned option. As we're building our visuals, this option will make it easier to align the edges of our visuals and keep everything looking nice and tidy. Now that we're done, click the OK button to exit options. You'll see a prompt that says enabling these preview features requires you to restart Power BI Desktop. So click the OK button again, and then let's exit Desktop again and reopen it again. Now, To verify that our preview features are available to us, we can check a few places. First, notice how the Insert section of the Home tab on our ribbon has changed. This is a strong indicator that we're now using the On-Object Interaction feature, which is the big interface change from 2023 we alluded to in our previous video. Furthermore, under this Visualizations menu, you should see the Shape Map visual, which is in preview as of the time I'm recording this video. Again, another indication that our enabling of preview features is working. Anyway, that's how you can enable preview features and make other changes to Power BI desktop options. At this point, we should be ready to begin building our first report. So, I'll see you in our next video. Now that we're ready to build our first report, let's talk about a few methods for getting data. As we can see from our report canvas, Microsoft gives us some big prominent options to import data from Excel or SQL Server and even a pre-built sample data set. We're primarily going to be working with plain text files containing comma-separated values, otherwise known as CSV files. And, well, you can see that option isn't visible here. So the next best option is on the Home tab of our ribbon. You can see there's a whole section dedicated to data. And if we open up the menu under the Get Data button, we'll see an option to import text/CSV files. This is what we want. So select text/CSV, and you should get a pop-up file picker that asks you to choose the file you want to import. Find the location where you downloaded the exercise files for this course, open them up, then open up the Week 1 folder and select the file named US States. The next thing Power BI Desktop gives us is a preview of the data in that file. As you can probably tell already, it's a list of all states in the United States of America, plus the District of Columbia, which isn't really a state. Scrolling top to bottom and then left to right, you can see the top 20 rows of our data set, and we can see several columns arrayed horizontally. The delimiter menu allows us to choose which text delimiter to use when extracting the data from our file. If we change it to semicolon, for example, the preview changes and we actually get a nice preview of what the raw data looks like in these files. It's just text that's all mushed together. Each column's data is separated from the next column by a comma character. Also notice how the text values are contained within quotation marks. This is known as text qualification. This helps when we have text data that contains commas. In those circumstances, any commas contained within the quotation marks are just interpreted as part of the text, whereas any commas outside the quotation marks are interpreted as column separators. That's why these are known as comma-separated values files, because the commas that are outside the quotation marks are used to separate columns of values. Let's switch back to comma as our delimiter so the data looks better, and you can see how Power BI Desktop is using the comma delimiter to correctly interpret each column. Now we can either load, transform, or cancel, as you can see in the bottom right corner of the window. If we cancel, the window will close and we'll go back to a blank report canvas, so don't do that. But if we hit the load button, the data will go straight into our Power BI data model without making any changes. Now that sounds tempting, but I rarely ever use this option. I would guess I use the load button less than 1% of the time I'm developing in Power BI Desktop. In fact, I've seen it debated among other Power BI developers whether the transform data button should actually be the green button, because that is the one most people find themselves using. I mean, that's anecdotal and we have no data to support that, but based on my own experience, it's very rare when I import a data set that requires no editing. So almost all of the time, I'm going to use the transform data button. So let's do what I almost always do and let's hit that transform data button. This will open PowerQuery for the first time, and in our next video, I'll orient you to the layout of the PowerQuery editor. The first thing you'll notice is that the PowerQuery editor opens in its own window alongside Power BI Desktop. We can see this if we go to our Windows taskbar and hover over the Power BI icon, where we can see that one window is dedicated to Power BI Desktop, where we just came from, and another is dedicated to the PowerQuery editor, where we are now. The first thing I'll draw your attention to is the Close and Apply button in the upper left corner of PowerQuery, which will close that application and return you to Power BI Desktop. We'll use this button a lot, so go ahead and learn where it's located. Now let's orient ourselves to the PowerQuery editor itself. It's laid out similarly to Power BI Desktop, with a main work area in the center, surrounded by a ribbon up top and some panels on the left-hand and right-hand sides of the window. The main work area contains a preview of the data from our data source. The ribbon has all the tools and commands we need to manipulate and examine data inside PowerQuery. And to the left of the data preview is the Queries panel, which contains a list of all the queries we are working with. Queries can be organized and grouped in this panel. On the right-hand side of the data preview is our query settings, which allows us to change the name and description of the query that we're working on. But the main feature here is the section labeled Applied Steps. Going back to my whole lecture about baking a cake and creating your data recipe and all that stuff, well, this is where you're building your recipe. Each query on the left-hand panel is like a separate recipe, and this Applied Steps section on the right-hand side contains all the steps for each recipe. Next, let's take a look at the ribbon. We see several tabs, starting with the Home tab, where we can add new data sources to PowerQuery and do some basic manipulation of the data, such as adding or removing rows and merging queries together. The Transform tab is a big one. This has many tools to take an existing column of data in PowerQuery and make changes to it, such as by changing its data type, renaming it, splitting it into smaller components, extracting data from it, or even performing mathematical operations against it. To give you an example, I'll select the Name column and click the Replace Values button to tell it to replace all instances of the lowercase a with an asterisk symbol. The effect this has on our data is immediate. All of our US state names have been altered, so the lowercase letter a has been replaced with asterisks. The original data is gone. It's been altered by the transformation we just performed. Now, note that any transformation you perform using the Transform tab in PowerQuery will overwrite the data in the column you've selected. But let's be clear about what I mean when I say it will overwrite it. Nothing you do in PowerQuery is capable of overwriting the data in the CSV file itself. PowerQuery cannot overwrite the data in the data source. PowerQuery works by copying the data from the data source into the PowerQuery mashup engine, running everything through your data recipe, and then loading the results into the Power BI data model. Throughout all of that, the data source will always remain intact. Now, notice how our recipe has been updated with a new step. There's now a Replaced Value step, which wasn't there before. If I right-click on the step, I get a menu of several options, including deleting the step, renaming it, editing it, or changing the order of our recipe by moving the step up or down. Let's suppose instead of replacing the lowercase letter a, I actually want to replace the lowercase letter e. I just need to edit the step. So I can either select that option from this menu, or I can select the little gear icon to the right of the name of the step in our recipe. It reopens the same dialog we saw a moment ago, and I'll just tell it to replace the lowercase letter e this time and click OK. And now we see different results in our data preview. So you can see that some steps in our recipe can be changed after they've been applied. Now I'm going to hit the delete button to the left of the query step to remove it from our recipe and return everything to normal. So if the Transform tab allows us to overwrite existing values from our data source inside PowerQuery, the Add Column tab lets us do many of the same operations. But instead of overwriting, these will add new columns to PowerQuery with the results. This tab is extremely useful for adding new columns from existing data or by generating entirely new data using conditional logic. Just as a couple of examples. For instance, if I want to add a new column that retrieves only the first letter of each state's name, I can go to the Extract menu, select First Characters, and input the number 1, then click OK. This will extract the first letter from the start of each state name and add it as a new column in the PowerQuery editor, which you can see right here. Notice our recipe has been updated with a new step titled Inserted First Characters. Now let's go to the View tab on our ribbon. This has some great features for profiling our data, as well as viewing the underlying code for our queries and looking at the dependencies between our various queries. For now, just make Speaking of the formula bar, which we mentioned at the end of our last video, let's locate its position at the top of our data preview. The formula bar displays the PowerQuery M formula that is generated by our transformations here in the PowerQuery editor. When you look at this formula, you can piece together what it did for us. It added a column to a table, named that column first characters, and ran a quick operation using the text.start function to extract the first character of each state's name from our state name column. This part in square brackets here is the column reference for our state's name column. Finally, after this comma here, the formula is setting our new column to use the text data type. We'll cover data types in PowerQuery in one of our next videos. So the formula bar is giving us just the code for this one step in our recipe. What if we want to see all the code behind all the steps in our recipe? For that, we can click on the Advanced Editor button, which is visible on both the Home tab and the View tab. Opening the Advanced Editor will open a new window where we can see the complete PowerQuery M code that has been generated by everything we've done so far. The query is divided into two main sections. The let section, which begins on line 1, is a series of declarations. On line 2, we've declared that our source step will retrieve a CSV file from our hard drive. On line 3, we've declared that the promoted header step will take the output of our source step and turn the first row of data in that file into the column headers that we see in our data preview. On line 4, we've declared also that the changed type step will set the data types for all of our fields, and on line 5, we've declared that the inserted first character step will add a new column to our data that extracts the first character from the start of each state's name. Notice how each step in this section references the step before it. Inserted first characters references changed type, which references promoted headers, which references source. Most PowerQuery M queries operate in this very linear fashion, where you're building a sequence of steps. Again, this goes back to the whole recipe analogy. Below that, in the section that starts with N on line 6, the output of our inserted first character step is returned, and this will be the final output of our query. Unless we add additional steps, of course. This query is very linear, but not all queries in PowerQuery operate this way. You can actually make pretty complex queries that use branching and nested logic, similar to how you can write nested formulas in Microsoft Excel. Now, like I said at the start of the course, we are not going to try writing raw PowerQuery M code in this course. We'll maybe tweak a few formulas in small places, but we won't be messing with anything nearly as complicated as what I just described. The main reason I'm showing you this is so you can understand how PowerQuery M code is generated, what it looks like, and so I can give you a basic idea of how it works. When we're done with the Advanced Editor, we can hit the Done button to close it and return to the data preview. Next, let's delete the step named Inserted First Characters. We just created that step to demonstrate some features, but we don't actually want that in our model. Now that we understand better how PowerQuery works, in the next video I'll show you how we can use the column profiling features in PowerQuery to examine our data a little bit more closely. Column profiling is useful for examining your data for errors and inconsistencies, and can help you identify issues you might need to fix in PowerQuery, such as data with misspelled words or data with invalid values. You should get in the habit of using these features anytime you're using PowerQuery because they can really save you a lot of time and trouble. To see the various column profiling features, click on the View tab in the PowerQuery editor. Let's start by selecting the Census Division Name column, then enabling the Column Profile feature, and watch what happens. The bottom part of our screen is suddenly taken up by two sections. On the left, we have Column Statistics, and on the right, we have Value Distribution. Column Statistics gives us a summary of the values in our column. In this case, it tells us that there are 51 values in this column, but only 9 of those values are distinct. That means our data contains 9 different census divisions spread across our 51 rows of data. At the bottom, we also see the minimum and maximum values. Since we're dealing with text data in this column, that just means the minimum value is the first value in alphabetical order, while the max value is the last value in alphabetical order. Also notice how it tells us that there are no unique values in this column. Now, you might be wondering what the difference is between distinct values and unique values. Distinct values is a count of each value that appears at least once in the column, whereas unique values is a count of each value that appears only once in the column. To illustrate this, let's actually go back and select our state name column and look at the results. We see 51 distinct values and also 51 unique values. That's because each value appears once and only once in this column. When we scroll back to look at the census division name column, we still have 9 distinct values because there are 9 different census divisions, but there are no unique values because each census division appears in this column more than one time. Looking at the unique values in the column statistics can be a helpful method for identifying outliers in a situation where maybe you don't expect to find any. Now let's look at the value distribution on the right-hand side. This section takes each of the 9 distinct values in our column and gives us a simple bar chart that visualizes the frequency of each value. In other words, the South Atlantic Census Division appears most frequently in our column, so its bar is the largest. Meanwhile, the Mid-Atlantic Division appears least frequently, so its bar is the smallest. Again, this kind of thing can help you spot anomalies in your data. Let's check some of the other columns while we're here. We can see that the census region name column also has 51 rows, but only 4 distinct values. This is interesting because it indicates that census regions are bigger than census divisions, which implies that there might be a parent-child relationship here. Census regions are bigger, so the census division is probably subordinate to the region. In other words, regions are the parents and divisions are the children. This is going to be very useful a couple of videos from now, so make sure to remember that distinction and that parent-child relationship. Then, if we go back to the left and examine our state name and state abbreviation columns, we'll just see those 51 rows with 51 unique values. The data is still sorted alphabetically, so our minimum state is Alaska when we look at the abbreviation column, or AK, or Alabama when looking at the state name column. Next, let's look at column distribution. When we enable this feature, a little section gets added underneath our column headers in the data preview section. You can probably see that this is just a more abbreviated version of the column profile feature. It gives you a simple chart that visualizes the distribution of each distinct value in the column, and it will tell you how many distinct values are present in the column. This especially becomes noticeable when we look at census regions and census divisions toward the tail end of our query. The last column profiling feature is column quality, which, when enabled, will display another small section between the column distribution and the column header. This displays different percentages showing you how much of each column is populated by valid data, or that has errors, or is empty with no data at all. For instance, the Associated Press column here shows 2% of its values are empty and 98% are valid. Now that we've examined our columns using the profiling features, in our next video we'll discuss the different types of data that we can work with in PowerQuery and how you can change the data type of a column. When PowerQuery first loads data from your data source, it will scan each column and attempt to automatically assign a data type. The data type of each column in the PowerQuery editor can be determined by looking at the icon to the left of the column name on each column. In the case of our U.S. states data, we see every column has either a 1, 2, 3 icon or an ABC icon next to its name. Let's talk about the various data types available in PowerQuery and what they mean. I'm going to click on the small ABC icon on the name column. This displays a list of all the data types available in PowerQuery, along with the icons that are used to symbolize each one. We see options for decimal numbers, whole numbers, or integers, and percentages, as well as options for dates, times, and durations. We can see text values, which are also known as strings, and true-false values, which are also known as logical or Boolean values. Columns can even contain images and other data stored as binary values. So, the small 1, 2, 3 icon next to our sort column indicates the column is a whole number, while the ABC icon next to our status column indicates that particular column is text. Note that numeric columns can only contain numbers, but text columns can contain both letters and numbers. For this reason, if you were to examine street address data, for example, the number 555 on its own would be classified as a whole number. But if you had a column that said 555 North Main Street, PowerQuery would classify that as text. Assigning data types to our columns not only makes it easier to classify the types of data they contain, but it also helps us determine what kinds of transformations we can perform against those columns. Columns in PowerQuery can be processed in a lot of different ways, depending on what data type each column is. For example, we can perform mathematical operations against numeric columns, but not against text columns. We can find and replace text inside of columns with a text data type, and we can combine different text columns together, such as by combining first and last names. But we can't combine dates. However, we can compare two dates to each other to see how far apart they are in terms of years, months, days, hours, and so forth. Sometimes, if PowerQuery is unsure of how to classify a column, it will use the default data type, which is denoted by a small icon with an ABC and 1, 2, 3. I'll demonstrate what this looks like and show you how we can change data types in PowerQuery. To do this, I'm going to go to the Add Column tab, then go to Custom Column, and I'm going to type in a quick and easy PowerQuery formula here. Date, time, dot, local, now, and then an open parenthesis and a close parenthesis. This formula is going to calculate the date and time value for this moment in time when the data is refreshed. This particular function, dateTimeLocalNow, simply calculates the current time in my local time zone, including the day, month, year, hour, minute, and second. I will name our column Now, and when we click OK, this is going to add a new column in the PowerQuery editor with the date and time visible. But notice how the data type is this little ABC123 icon. This denotes the default data type, which I like to refer to as untyped or unclassified. Our column looks like a date-time value, sure, but PowerQuery apparently wants us to explicitly tell what type of data this is. So to do that, I'll click the icon next to the column name and choose date/time from the list. Now, when I do that, the data itself doesn't appear any different, but notice that the icon now looks like a calendar with a little clock on top of it. This is PowerQuery's shorthand way of telling us that this column is now explicitly typed as a date-time column. So that's one way you can change data types in PowerQuery, by using that icon on each column. Another way you can do it is by right-clicking on the column, then find the Change Type menu, and you'll see the same options here. Now watch what happens when we try to change our column to a text data type. First of all, PowerQuery will ask if we want to replace the current step we just created, or if we want to add a new step to our recipe. I'm going to tell it to replace the current step, and now we can see that PowerQuery has changed our data to a text data type. Notice how the text data type automatically aligns its data to the left-hand side of each cell, while the numeric and date data types automatically align to the right-hand side of each cell. Now let's try transforming the column into a numeric data type. I'm going to go to the menu and select decimal number and replace current step and check out the results. The icon changes to a 1.2, as you can see, which symbolizes the decimal number data type, and our dates have been converted into numbers out to 5 decimal places. Now, if you weren't expecting that, it's important to know that dates inside tools like Microsoft Excel and Power BI are actually stored as serial numbers, where each day on the calendar is represented by a whole number, and everything smaller than a day's span of time is represented by a portion of that whole number, which is shown after the decimal. This makes it easier for tools like Excel and Power BI to calculate differences between various dates and times. Now let's see what happens if we change this to a date data type. You can see this actually removes the timestamp from our column and returns only the date portion. By that same token, if we change our column to a time data type, it does the opposite. It removes the date portion of the column and it keeps the timestamp. So what if we try to change the column then to an invalid data type? To see that, let's try changing our column to a duration data type and watch what happens. Now the column is returning errors for all of our rows. And let's try it with the true-false data type as well. And we see that we get the same result. This tells us that the data in our column is apparently not compatible with either of these data types. We can confirm this by clicking on one of the error cells, which isolates the value for that particular row and column and displays our error message, which says dataformat.error, we couldn't convert to logical. And below that, it displays the value that it attempted to convert into that data type. Now let's do a little exercise to see how these kinds of errors can show up in our column profiles. To undo what we did here, let's delete that last step in our recipe. Then let's scroll back to the right and change our data type back to a date time value. Then let's go to our census region column. We're going to change the column type to text, which works fine. And then we're going to right-click, replace values. We're going to replace all instances of the number 3 with some text. Let's just write Power BI. Then we're going to get this column to show us a bunch of errors by trying to force it to convert its data back into numbers. So we'll go here and change it to whole number. As we can see, most of the rows successfully changed to numeric data, but we do have a bunch that are now displaying errors. If we look at the column profiling features now, the column quality area is telling us that 33% of the values in this column are errors. And if we go to the View tab and add column profile back to PowerQuery, we can also see that there are 17 errors out of a 51 total rows. This demonstrates another way you can use column profiling to identify issues in your data, which can sometimes be resolved by simply choosing the right data type, or by replacing erroneous values using the replace features in PowerQuery. Let's get back to normal by undoing everything we did. I'm going to right-click on the Added Custom step, and I'm going to select Delete Until End. This will delete this step in our recipe as well as all the steps after it, which gets us back to where we were when we started this video. Now we're ready to remove any data that we don't need. In the next video, we'll talk about how to choose columns in the PowerQuery editor. It is often the case that the data source you're using in Power BI has way more data than you need for the questions you're trying to answer. It could be that you have more rows than you need or more columns. One of the key principles of good dataset design in Power BI is to only load your dataset with the minimum amount of information that you need. When your datasets get large enough, limiting the amount of data you load into Power BI helps improve performance, because more columns and more rows will require more time to query and process all that extra data. So the more data you have, the more likely you are to see some slowdown in how your report performs. There are other benefits to limiting your data, such as simplifying the data model so it's easier to write documentation, but the biggest motivator here is going to be performance. The U.S. states data we're working with here isn't nearly big enough to be a performance concern, but it's still important to teach these best practices early and often. You can probably tell by looking at the data preview that not all of these columns are going to be useful for building a report. The only ones we really need are name, abbreviation, census region name, and census division name for the purpose of this exercise. Everything else is extraneous and we can remove it. So to remove columns, we have 3 options. We can select the columns we want and right-click, and then select Remove Other Columns, like so. This removes all columns except the ones we've selected. Now let's go back and look at a different method. The next way to do this is to select all the columns we want to remove, and then right-click and select the Remove feature, which will only remove the columns that we've selected. Now, the problem with both of these approaches, using either Remove or Remove Other Columns, is that if you're dealing with a lot of columns in your data source, this can involve a lot of scrolling and clicking, and it's just not very efficient. It's really tedious, to be honest with you. So the approach that I prefer is to use the Choose Columns feature, which can be accessed from 2 places. You'll see it on the Home tab in the Manage Columns section, or you can click this small button in the upper left corner of the data preview where you'll find a Choose Columns option. So click that and you'll get a pop-up menu that displays all of the columns in our data preview. First, click the Select All Columns button to unselect everything, then select Name, Abbreviation, Census Region Name, and Census Division Name. Then, click OK. This adds a new step to our query named Removed Other Columns. And we can see our PowerQuery M formula, which uses an operation called table.selectColumns to get only the columns that we want. Next, let's rename our columns. This can be done by right-clicking on each column and selecting the Rename option, or you can simply double left-click on each column header and rename them one by one. In this case, let's change name to state. Let's capitalize abbreviation, and then let's change census region name to just census region, and we'll change census division name to just census division. The reason I'm doing this is to just simplify our column names and make them easier to read. Now, let's take a moment to open the Advanced Editor in PowerQuery and review the latest version of our PowerQuery M code. Note that we now have 5 transformation steps on lines 2 through 6 that mirror our recipe in the right-hand Query Settings panel. Finally, let's rename our query from US States to just States. We can do this by either changing it in the Query Settings panel on the right-hand side, or by changing it in the Queries panel on the left-hand side. Right-clicking a query in the Queries panel will display a list of options, one of these being the Rename option. So select it, and then type in States. I'm just doing this to simplify the names of our tables in the data model. And with that, we're finished. We're ready to load this data into our Power BI data model. I know that was a lot of content over the last several videos, but that was just a basic overview of the PowerQuery editor. I wanted to introduce you to the layout, the formula language, data types, and how to use column profiling, because these are all things you need to pay attention to every time you use PowerQuery. Throughout this course, we will repeat many of the same steps we just did, evaluating each sample data set we work with to understand what kind of data we're working with, how the columns are distributed, and what the PowerQuery M formula language is doing to generate the final data set for our report. Now, to exit the PowerQuery editor and return to Power BI Desktop, simply go to the Home tab of the ribbon and click the Close and Apply button. This will exit PowerQuery, and we'll briefly see a pop-up window in Power BI Desktop that announces to us that it is querying the data from our US States CSV file for the first time. Once it's done loading, we're ready to start building our report, and we're going to jump right into that process in our next video. Now that we have returned to Power BI Desktop, PowerQuery has copied the data from our CSV file data source for the first time and loaded it into our data model successfully. If we look at the Data tab on the far right side of the application and open it up, we can see a table named States is now visible with 4 columns named Abbreviation, Census Division, Census Region, and State. Let's take a moment to look at the Data View and Model View in Power BI Desktop to see what they look like. In the Data View, we can see our States table and all of its data. It contains 4 columns and 51 rows, exactly what we told PowerQuery to produce for us. We can use the Data View to explore the data interactively, such as by filtering the census region to just the West region, like so, which returns 13 filtered rows. I can then clear that filter by going back and selecting Clear Filter. Next, let's head to the Model View, which gives us more of a top-down view of our data set. We can click and drag the table around the diagram, but there's not much else here to work with, so that doesn't really accomplish anything. We only have one table so far, the States table, so there's not much to look at. Notice the little eyeball icons at the top of the table and next to each column name. These allow us to control the visibility of columns and tables in the report view. That means if there are certain columns and tables in the model that maybe we need for calculation purposes but are not actually used in the report, we can use these buttons to make them invisible. The data will still be in the data set, it just won't be visible in the report view. We'll come back to the model view in later videos, but for now, let's return to the report view and start visualizing some data. Let's begin with a very basic table visual. To insert a table, you can use the Visuals menu on either the Home tab or on the Insert tab. Or you can right-click anywhere in the report canvas and say Add Visual. If you do the Add Visual approach, it defaults me to a column chart, which isn't what we want. But notice how there's a menu to the right side of the visual. This is the On-Object Editing feature of Power BI, which became available in 2023. This is still a preview feature as of the time I'm recording this video, so it could look different for you depending on whether Microsoft makes any changes to this feature by the time you take this course. On this menu, I can see other types of visuals available, including the table visual itself, which is right here. So I'll select that to convert this from a column chart to a table. Then we can start adding data to our table. There are multiple ways to add columns to a visual. You can use the On-Object Editor by clicking this Add Data button, which opens up another menu to the side where you can see all of your tables and columns that are available to be added. So I'll use that to add the state column to our table. You can also drag and drop columns from the data panel over to the visual, like so. Or you can use the checkbox next to each column on the data panel. All three approaches work great for adding data to your visuals. Now, notice the size of our visual and notice that we have both horizontal and vertical scroll bars along the bottom and right edges of our visual. Also notice how our visual is bounded on all sides by lines, which let us know that this is the current visual we have selected in the report canvas. And there are small circles at each corner of the visual, plus some circles at the middle of each edge. Through left-clicking them, these circles can be used to click and drag the boundaries of the visual, making it larger or smaller, taller or wider. You can also move a visual around the report canvas by doing a little click and drag with your mouse. So let's move our visual to the right side of the canvas, and then let's extend its height. Notice that for each column we added, our table visual added a column header to the top of the visual. Table visuals are simple and versatile tools for reporting in Power BI. They don't consist of many elements. You just have rows and columns, and then you have the column headers. But tables are powerful because they can be interactively sorted by left-clicking on the column headers, like so, to arrange our data in whatever order we want. Also, tables have some features that other Power BI visuals don't have. For instance, tables can include images and icons, as well as hyperlinks that allow you to link your users to external web addresses. Tables also can use conditional formatting, which changes how the table cells are formatted based on their data, and they can include sparklines, which are small visual elements that are the size of a single table cell, but which can summarize trends in your data. So I really like tables in Power BI. They're actually one of my favorite visuals to use. Now, let's remove some of the data from our table and watch how that changes its appearance. I'm going to go to the On-Object Editor, and then I'm going to click the small X next to the state and abbreviation columns to remove them from the table. Notice that all of a sudden we have fewer rows in our table than we had before. That's because the table is only returning distinct values from our states data. In this case, it's returning each distinct combination of census division and census region. If we go a step further and remove the census division from our states table, we now have only 4 rows. This is standard behavior for the table visual. Let's actually add our other columns back to the table, starting with census division, and then state, and then abbreviation. And now let's look at various ways that we can format the table. When we right-click on a table, we'll see a pop-up menu that displays a Format option. Left-clicking this option will open the Format panel on the right side of the report canvas. I'm going to close this Filters panel to give us a little bit more room to work, and I'm going to click and drag the edge of the Format panel so we have a little bit more room to see things. The Format panel gives us a lot of different ways to change the appearance of our table inside these expandable and collapsible sections. And notice how there are 2 tabs we can look at. There is a Visual tab and a Properties tab. The Visual tab lets us change fonts, colors, and other attributes of how the visual visually represents its data. The Properties tab, meanwhile, lets us configure other attributes of the table visual, such as tooltips, which are little pop-ups that appear when you hover over the data. We won't look at all of these formatting possibilities, but let's hit a few of them. First, let's talk about style presets. The table visual, as you can see, defaults to a basic appearance where we have alternating row shading with a white row followed by a gray row and so forth. With the style presets, we can quickly toggle between several different styles, such as a minimal appearance where the alternating row shading is gone. So just open up the menu and select minimal to see that. The bold header option, meanwhile, uses that same style, but with a dark background on the column headers. Take a few minutes to explore these various options and find the one that appeals to you the most. I personally like the sparse preset, so I'm going to use that one. Next, let's give our table a title. Visual titles can either be static text or they can be generated dynamically using DAX formulas. We'll cover how to do dynamic titles with DAX later in the course. So for now, let's just give our table a simple title. We'll turn on the title option and expand this section, and we'll just type in the words US States. And notice how we have options to change the font and text alignment of our title, such as by centering it in the visual, or we can even add a little background color. We can also go a little bit further down to the subtitle section and turn that on. And let's add a little subtitle here that says broken down by census region and division. Finally, if we turn on the divider option, it will add a small horizontal line between the title and subtitle and the rest of our visual. Now let's collapse the title section and look at our grid section. With table visuals, we can add horizontal and vertical grid lines as a way to visually separate our rows and columns. Now, the sparse preset I chose doesn't use grid lines, but we can override the preset and re-enable those grid lines by just hitting each little toggle button here, and that's still a pretty good looking table. And we can change the color of the grid lines or their thickness using these options, such as by choosing orange and then making it super thick like this. That kind of looks terrible, so what I'd like to do now is reset to the default grid line settings. I can do that by hitting the Reset to Default button right here, which is going to get rid of the grid lines and return us to the default settings for that sparse preset. I'll turn the grid lines back on for just a moment and point out that this Reset to Default option is available in all of these sections at the bottom. We can also change the border color below our column headers by going to this drop down here and say changing it to orange and increasing its thickness once more. If we go down to the options subsection below, we can also modify the row padding of our visual. Maybe if we want to make the rows look a little bit more spaced out, or if we want to make them look more condensed, like so. Next, in the value section, we can add the alternating row shading back in by just choosing an alternate background color, like so. Or we can even choose an alternate text color, like so. I don't like the way that looks, so again, I'm going to hit that Reset to Default button and get us back to normal. Under the column headers section, we can change how the column headers are formatted, like by removing the background color and changing the text color, and even making the text bold. The next section is totals. Now, we don't have any totals in this table yet, so I'm going to skip this section and move right on to the specific column section, which we can use to change how a single column is formatted to differentiate it from the others. For example, if we pick the abbreviation column from our list here, we can give that column a different background color by selecting it from another drop-down menu here, and now the abbreviation column has a different background color compared to the other columns in our table. We can also change the alignment of the text if we want to. I'm going to skip the remaining sections because we're not ready to talk about them yet, but we'll come back to some of them later in the course. As we go through the course and experiment with different types of visuals, I strongly suggest you take a few moments each time to review the different formatting options that are available for each visual. They're all different, and some of them are pretty basic while others can do some really amazing things. And now that we've had our table filled out and formatted, in the next video, we'll add another visual to our report canvas, and we'll explore how visuals can interact with each other in Power BI. In our previous video, we added a single table visual to our report canvas and made some basic formatting changes to it. Now, let's add some more visuals to the report canvas and explore how all of these visuals can interact with each other. First, let's add a shape map visual that allows us to see all of the US states on an interactive map. Go to your Visuals menu and open it, and locate the one named Shape Map. If you don't see the Shape Map visual, go to the File menu, open Options, and make sure that the Shape Map visual is enabled under the Preview Features setting, like we discussed in one of our earlier videos. Click the Shape Map icon to add that visual to our canvas, and then let's click and resize it so that it takes up the upper left quadrant of our report canvas. And now let's add some data to it. On the editor, you'll notice how we have 4 different places where we can insert data on this visual. Remember that the table visual only had one area, but this shape map has 4 different ones we can choose from: location, legend, color saturation, and tooltip. Let's begin by adding our state column to the location section, and the results are immediate. We get a map of the United States with all of the states shaded in blue. Now watch what happens when we left-click to select a state on that map, such as Colorado. Our selection on the shape map automatically filters the data in our table visual, so now it only displays Colorado, which we can see is in the West Census region and is in the Mountain Census division. By default, visuals in the Power BI report will interact with each other, so if you click on an item in one visual, it will filter items in other visuals on the same page. Let's left-click on Colorado again to deselect it, and then let's go to our table and left-click to select a state from there, such as Alaska. Now the state of Alaska is filtered on our map, appearing in blue while all other states are gray. So let's dig into this a little bit more, shall we? Let's add a third visual to our report canvas, and this time let's add a bar chart. So I'm going to go up to the Insert tab, find a bar chart, and click to add it to the bottom left corner of our report canvas. Then let's add the census region column to both the x-axis and y-axis of the chart. And we get a bar chart that visually displays the frequency of each census region in our data. If we hover over the South region, it tells us in a tooltip that there are 17 states in that region. And if we hover over the West region, the tooltip tells us that there are 13 states. Also notice that when I added the census region to the x-axis, the visual automatically changes to say that it's doing a count of the census region. So to determine the frequency of each census region, Power BI is just counting the number of rows where it finds each region. Now let's select the South region from our bar chart and watch how it affects the other visuals on the page. Our map is filtered so that it only shows the states that are in the South region, and our table is filtered to just the rows where the census region is South. And we can see, based on the fact that the census division column is already sorted in alphabetical order, that we have 4 states in the East South Central Division, and we have 9 states in the South Atlantic Division, and 4 more states in the West South Central Division. Then we can use our bar chart to cycle through each of the other regions in the United States: West, Midwest, and Northeast. Notice how easy all of this was. I didn't have to do any coding to create this interactivity. It's all done by default in Power BI. So what happens if I select North Carolina from our map? We already know the table visual will filter down to just that state, right? But what is the effect on our new bar chart? Well, as we can see, the chart is filtered, but we get a dark blue area on the south region of our bar chart, while all the other data switches to this lighter blue color. This is an example of highlighting in visual interactions. There are 3 possible visual interactions in Power BI: highlighting, filtering, and none. Each visual on the page has this setting, which determines how it interacts with all the other visuals on the page. To see the different interaction possibilities, select the map visual from our canvas, and then go to the Format tab on our ribbon. This tab shows up when you select a visual, and you'll see a button on the left that says Edit Interactions. Clicking to toggle this button on will cause some new icons to appear in our report canvas. You'll see 2 or 3 icons that are now subtly visible in the top right corner of our table visual and our bar chart. Let's zoom in on the bar chart icons to take a look. The location of these buttons is a big clue as to what they do. They control how the bar chart visual reacts whenever you change something on the selected visual. In this case, since our shape map visual is the one that we've selected, these buttons are telling us what happens to the bar chart when we change the shape map. Currently, highlighting is enabled, but watch how the bar chart changes when we switch it to the filter option by clicking it. Suddenly, the other census regions are gone, and we're just left with the south region on our bar chart. So you can see that filtering interactions will show only the data you selected, whereas highlighting interactions will show all the data, but it will shade the data you've selected in a darker color compared to the non-selected data. So highlighting versus filtering. Highlighting and filtering. Then, if we turn to the None option, the visual returns to its default state of not being filtered or highlighted at all. It simply will not react if you change the shape map, no matter which state you select. You can see that we still have North Carolina selected, but the bar chart looks the same as it always has. There's no highlighting or filtering that is happening. So what happens if we select a row from our table now? For instance, if I select the state of Tennessee. Well, the bar chart changes and we can see our selections are being highlighted. This is because we only changed how the shape map visual affects the bar chart. We didn't change how the table visual affects the bar chart. Now that the table visual is selected, as you can see from the little border around the table visual, we can use the None option here as well by selecting it on our bar chart. And now, regardless of which visual we use to select a given state in our United States, the bar chart visual remains constant and unchanged. Also notice that if I deselect my table visual by clicking into one of the empty areas of my report canvas, the interaction buttons at the top of each visual go away. They will only show up when you have selected a visual and when you have turned on the Edit Interactions feature on the Visual Format tab of your ribbon. Now you may have noted the fact that the shape map and table visuals both only have the Filter button and the None button available. This is because not every visual in Power BI supports the highlighting method. It is usually only supported on bar and column charts, as well as pie, donut, funnel, and tree map charts. There may be some others. This is not an exhaustive list. So you can see how using the Edit Interactions feature to configure the ways our visuals interact with each other is a good way to keep some data constant and unchanging by using the None option, or to show subsets of selected data within a larger context by using the highlighting option, or finally by narrowing down to a specific subset using the filtering option. And now, hopefully you're seeing how our Power BI report is starting to take shape. This is a very basic data set, but it works very well when illustrating these core concepts in Power BI. And speaking of core concepts, it's time for us to talk about DAX. So, in the next video, we'll start to define some measures using the DAX language. Measures are one of the most important concepts in Power BI development. Written using the DAX formula language, they are an integral part of every data model that attempts to aggregate data for reporting purposes. Remember from an earlier video in this course that measures are formulas stored in our data model that dynamically calculate in our report depending on what filters we have applied and how we're using them in our visuals. So when we define a measure in Power BI Desktop, all we're really doing is adding a text formula to our data model definition. But when that formula is applied in a Power BI visual, like the table, map, and bar chart that we built in our last two videos, you'll see how measures are used to perform these lightning-fast calculations against our data set. On the Home tab, you'll see two buttons near the center that you should make quick note of: New Measure and Quick Measure. We'll discuss how to use the Quick Measure feature later, but for now, let's just do a basic New Measure. Click the button, and that will open a formula bar directly below the ribbon. This is our DAX editor, and you can see it starts out with the text measure equals. Everything to the left of the equals sign is the name of the measure that we want to define. I want us to start by creating a measure that counts the number of states from our states table. So I'm going to name my measure states, and I'm going to write a simple formula, count, using the states state column, and then use a close parentheses to end the formula. And I can either, at this point, cancel the formula by clicking the X button to the left, or I can commit my formula by clicking the checkmark button also to the left. I can also commit my formula by hitting the Enter key from within the formula bar, or by simply clicking my mouse anywhere else in my report. I'm going to click the little checkmark button just to do it. To find where our measure went, let's collapse the Format panel on the right-hand side of Power BI and go back to the Data panel. And the first thing you should notice is that the measure is showing up in our States table in the Data panel. It has a calculator icon next to it, which symbolizes the fact that this is a measure in our data model. It almost looks like we've added another column to our table, but that's actually misleading. If we go to the data view for a moment, you'll see that our states table still only has 4 columns in it. And this is because, as we've talked about, measures aren't columns. Like I said, it's just a formula that is stored in our data model, and that formula only gets evaluated when you add it to a visual in the Power BI report. So, as a result, measures will not show up in the data view. The second thing to notice is that when you've selected the measure from the data panel, we have a new tab on our ribbon called Measure Tools. This tab can be used to rename the measure or change how it is formatted. And in particular, notice how there's a property on the left called the Home Table. Remember what I just said a moment ago, measures aren't columns. However, they still get attached to tables in your data model, although this is purely just a form of organization. It's a way for Power BI to logically group your measures, although measures really do not care what table you attach them to. Again, they're dynamic calculations, and they exist independently of the tables in your data model. They sort of sit on top of the tables. That's how I like to think of them, in a manner of speaking. And they just reach down into those tables to select whatever data they need to run their calculations. Now, a very common practice among seasoned Power BI developers is to create something called a measure table in our data models. This is just an empty table whose only purpose is to store measures. We create measures and then we attach them to the measure table, so all of our measures are grouped together in one place somewhere in our model. And I'll show you quickly how to create a measure table for your model. First, let's go to the model view. Then, on the Home tab, let's click the button for Enter Data. This will open up a pop-up with the name Create Table at the top, and this is where we can literally type data into our model, or we can copy and paste data from a spreadsheet or other data source. The Enter Data feature is useful for situations in Power BI where you have a minuscule amount of data that you want to add, and that data does not need to be refreshed. So it's really good for static values that don't change often or at all. Now, if we're going to use this as a measure table, I'm just going to change the name of my table to measures, but I'm going to insert an underscore at the beginning of the name. I'm doing this for 2 reasons. First, Power BI won't let me create a table just named measures. And second, this underscore will help with the alphabetical sorting of my tables in the data panel. It ensures that my measures table will always appear at the top of the data panel, above all of my other tables. And you can see we've already got an empty cell in our table. And it really doesn't matter what you name this column here. Right now it's named column 1, and I prefer to just put a hyphen or underscore in here, just as a subtle little placeholder character. So I'm going to add an underscore and then hit enter. And then I'm ready to create our table. So I'm going to click the load button to create this in our model. And you can see now that it's been added to our model here on the model view. And if we go over to the data view now and select that table from our list in the data panel, you can see it's just an empty table with no rows in it. Now, because our placeholder column has no data in it, there's really no purpose in showing it in the report view. So let's go back to the model view now, and let's actually make that placeholder column invisible by clicking the little eyeball icon. Now, to move our states measure to our new measure table, let's select it from the states table. And then notice how there's a big properties panel on the right-hand side that allows us to configure all the properties of our measure. Notice how one of these properties is our home table, same as we saw it on the Measure Tools tab earlier. If we change the home table of our measure from states to measures, we can see the measure moves from one table to the other. Not only that, but look at how our table icon has changed in the data panel. It changed from being a table, like the states table that you see directly below it, to being a calculator icon. This calculator icon is what Power BI uses to symbolize a measured table. Again, it doesn't really matter where you keep your measures in Power BI. However, using measure tables in our models is a best practice that is generally agreed upon among most Power BI professionals. We do this because it helps keep measures in a consolidated location separate from everything else in our model. And this becomes extremely useful when you're dealing with dozens of measures in Power BI, which is frankly not uncommon. Okay, I know you're eager to put this measure into our report, so let's tackle that in the next video. Now that we've defined our first measure, let's add it to our table visual and see what happens. We'll select the table, and then click the states measure to add it. A new column is added to the visual, but we also get a new total row at the bottom of the table, and that total row is summing our measure, displaying a total of 51 states in our data set. This is, of course, where I need to remind you that the United States only has 50 states, but that the District of Columbia is included in our data set. So we're technically working with 51 rows of data here. What happens then if we remove the name and abbreviation columns from our table like we did earlier? Let's open up the OnObject Editor by clicking this button in the upper left corner, and let's remove state and abbreviation. Our table collapses down to just 9 rows with 1 row per census division. Our measure is still counting the number of states in our table, but it's aggregating that number across our census divisions. And if we take this a step further and remove census division from our table, it collapses down to just 4 rows. So this is an example of the dynamic calculation that occurs in DAX and how flexible measures can be in Power BI. The information that a DAX measure returns is dependent on its visual context. So if you display a table listing each state individually, like we had earlier, and add the measure, you'll just get the number 1 over and over again. Like this. But if you remove individual states and only display the regions and divisions, like we're doing now, that measure will aggregate its results at those levels. So I'm going to use undo to add states back into our table. And then let's remove the measure as well. But let's add it to our other visuals. Let's first go to our bar chart, and let's replace the column on the x-axis that we used earlier and add our states measure. You'll notice that the visual really doesn't change at all, and that's expected. In a later video, I'll talk more about the difference between explicit measures, which are those defined in DAX, and implicit measures, which are those not defined in DAX. So stay tuned for that because it's an extremely important discussion in the world of Power BI. For now, let's move on to our shape map visual. Now, what I really want to do with the report is try to create some visual distinction between these census regions. We have 4 different regions, but in our report as they are now, they're currently all the same color. So let's see what happens when we add our states measure to the color saturation box of our shape map, we'll open up the OnObject editor and go to color saturation and add our states measure. Well, that didn't do anything. So, okay, what if we add the census region to the legend box of our shape map? Let's do that. And oh, that's a lot more interesting, isn't it? Now we have the different regions shaded in different colors, with the South region in orange, the West region in purple, the Midwest region in blue, and the Northeast region in, well, dark blue, navy blue, whatever that is. So let's try this out with our bar chart now. We'll select it, and what happens if we go to the OnObject editor and add census region to the legend section here? Well, we get the same result. Our chart is now shading each bar differently based on what region it is. And if we start to select bars from the bar chart, we get this really cool interactivity where selecting the orange bar highlights the orange region on our map, and selecting the purple bar highlights the purple region on our map, and so on and so forth. Now, it may seem trivial, but using color as a visual cue is an enormous component of good report and dashboard design, regardless of which tool you're using, regardless of whether you're using Power BI or Tableau or Click or something else. Something as simple as creating a continuity of color between different parts of your report can be an enormous visual aid to your users, allowing their brains to more quickly associate groups of data. So this is where technology actually meets up with human psychology, and we're going to talk about this several times throughout the course. And if you're wondering how Power BI knew to keep the colors consistent across both of these different visuals, the answer has to do with the alphabetical ordering of the visuals and the color palette of our report. So let's go to our shape map visual and right-click and select Format to open up the Format panel once more. And then, in the Format panel, let's find the section called Fill Colors. Under here, you will find a list of all of the fill colors that are used in our shape map visual, and the color assigned to each region. If we open each color and look at the palette, we see that white and black are automatically our first two colors, but every color after that is part of the particular palette that we're using in Power BI Desktop, starting with blue, and then the darker blue, and then orange, purple, pink, slightly lighter purple, gold, and then finally red. So all Power BI did here was sort our census regions alphabetically. Then it took the color palette and, starting at the blue color, simply went from left to right across the palette and assigned each of these primary colors to one of our census regions. It's as simple as that. So one more trick before we leave this video. We've got this great continuity of color between the map and the bar chart, but don't you think that our table visual looks a little plain by comparison? How can we use Power BI Desktop to add colors to the table visual and connect all three of these different visuals together? The answer is a feature of our table visual known as conditional formatting. We're going to do a longer video dedicated to conditional formatting later in the course, but this right here is just too good of an opportunity to demo that feature's capabilities. Our goal is to shade each of the cells of our census region column the same color as the ones they are assigned in the shape map and the bar chart. To accomplish this, select the table visual and then go to the Format panel, and then find and expand the section named Cell Elements. This area of the table formatting allows us to customize each column with different styles. So select the Census Region column from the drop-down menu and toggle on the option below it that says Background Color. It's going to open up a pop-up rule builder where we can specify what happens to each cell based on certain rules. In this case, we're going to change the background color of each cell based on the value of the census region column. We have 4 different regions, each with its own color, so we're going to use the New Rule button here to create 4 different rules, and then we're going to fill in the name of each region in these boxes, starting with Midwest, then Northeast, then South, and finally West. Then we're going to use the color picker next to each rule to pick the color for each region. So for Midwest, we will select blue. For Northeast, the darker blue. For South, orange. And for West, purple. Once we've done that, we'll click OK. And the background color of each cell in the table now matches the colors from the shape map and the bar chart. Now, our font in the census region column is black, and you can see that the text is getting lost in the background with these darker colors like the purples and the dark blue. It's really hard to read West and Northeast on these particular cells. So we can fix this by going back to our Format panel, going to the specific column section, and then make sure that we have selected Census Region from the drop-down menu labeled Series, and then change the text color setting to white. And that looks way better. And now if we click on the regions in our bar chart like we were doing earlier, we can see how we get this really nice consistency of colors for each region across all 3 visuals of our report. Before we start this next unit, I'm going to spotlight some formatting changes I made to improve the appearance of our report. First, on the shape map visual, I went to the Fill Colors section of the format settings and changed the border color to white, which drew a white border around all of the US states. I think this makes them a lot easier to distinguish, especially among those darker colors. Second, I toggled off the legend property of the shape map because, well, when you look around our page, you can't help but conclude that the legend was kind of redundant. Our bar chart and our table both use colors to identify each of the census regions, so we can actually use these as an even better legend when you think about it. The map's own legend was just taking up space, so I turned it off. Finally, on the bar chart, I turned on data labels, which you can see at the end of each of these horizontal bars. The data label just gives us a quick reference to how many states are in each region. And also notice that on the bar chart I turned off the legend as well. Okay, now it's time to talk about slicers, one of the most commonly used features in Power BI to filter data interactively. A slicer is really little more than just a filter control that sits on the report page, but they come in so many different flavors and they're extremely useful for letting your report users slice and dice the data in various ways. In this video, we'll add a simple slicer to our report page along with something called a hierarchy, and we'll explore how these features let us enhance the usability of our report. So despite their name and how I just described them, slicers are technically visuals in Power BI. In Desktop, you'll find them under the Visuals menu in their own little section called Slicer. Click to add it to your report page, and let's nestle it up in the upper left corner above our shape map. Then let's add the census division to our slicer. And notice how it populates with a distinct list of each division with a checkbox next to each one. Now let's open up the slicer's format settings and explore a bit more. The first and most important section to look at is the Slicer Settings section. Under the Style menu, we can change our division slicer from a list to a tiled list, like you see here, or we can change it to a drop-down menu, like so. Any of these options are fine, although a drop-down menu will take up less space than the other options. So let's select a tiled list for now. Now let's click through our slicer and watch how it changes the report. we can now interactively select each of the census divisions in the United States by just clicking one of these tiles. And we can select multiple divisions by holding the Control key and clicking at the same time. Then, to clear our slicer selection so we can return to all divisions being selected, we can either click to deselect each option, or we can click the small eraser button in the upper right corner of the slicer to clear all selections with one click. Let's go back to the format settings and look at the next subsection, which is titled Selection. As you can see, we can make the slicer into a single select slicer, which means you can only choose one item at a time, like this. If we disable single select and go back to multi-select with Control, we can actually turn that off so we can select multiple items without having to use the Control key. Finally, there's another option which allows us to show a Select All option in our list, so we can quickly select every option in our slicer without needing multiple clicks through the mouse. So let's keep the slicer as it is for now. I'm going to click the Select All button again, and then I'm going to turn off the Select All feature and return to multi-select with Control. And now let's talk about hierarchies. In Power BI data modeling, a hierarchy is a combination of two or more columns that have a relationship to each other. Specifically, a parent-child relationship, where one column is treated as a child or subordinate of the other column. Some common examples of this would be things like sections and subsections, managers and employees, or continents and countries. In our course, with this U.S. states dataset, a perfect example here is the relationship between census regions and census divisions. Divisions are smaller entities, and each division belongs to a census region, which is larger and consists of multiple census divisions. So this illustrates the concept of parent-child relationships and hierarchies in Power BI quite beautifully. Now, there are two basic ways to create hierarchies in Power BI Desktop. You can create an implied hierarchy on certain visuals by just putting two columns next to each other. We kind of saw this in one of our earlier videos when we just had the census region and census division in our table visual. Each division appeared once, but right next to its name was the name of the census region it belongs to. And you can do this with slicers as well. If we go back to our slicer and go to the OnObject Editor and add census region, and then put census region above the census division on our editor right here, two things are going to happen. First of all, Power BI automatically converted our slicer from a tiled slicer to the list version, because the tiled slicer does not support hierarchies. And you'll also see that our census regions are now visible in our slicer with a little down arrow next to each one. I'm actually going to change our slicer style to a drop down because I think this will look a little bit better, and then I'll open up the drop down. There we go. If we click one of these arrows, such as the Midwest one, it expands the region to show each division underneath it. And we can do the same with the Northeast region. This is an implied hierarchy in action. We can then click either the whole census region, like Northeast, and look at our results, or we can click a single census region, like Mid-Atlantic, and again, see the results. I'm going to click the Clear button to remove our selection and return to our regular state now. Now, let's look at how to create an explicit hierarchy. Let's go back to our slicer, go to the OnObject Editor, and remove our two columns. Now, let's go to our Data panel, and let's right-click on the Census Region column and find the option to Create Hierarchy. This will add a new object to our states table, which I'm going to name Census Area. So to rename this, I'm going to go to Options, Rename, and call this Census Areas. Notice how it has a small hierarchy icon next to it to distinguish it from the other objects in our table. Then let's add the census division column to our new census areas hierarchy. To do this, right-click on census division, find Add to Hierarchy, and then add it to the census areas hierarchy. This adds the division to the hierarchy underneath census region, which you'll see if you expand the census areas hierarchy. And now our explicit hierarchy is able to filter data in our report. So let's click and drag it onto our slicer and open up the drop-down menu, and it looks exactly like our implicit hierarchy did. So if both explicit and implicit hierarchies accomplish the same thing with no difference in behavior, why do we have both options? I think the best answer has to do with convenience for other report developers and for your users. If you give them an explicit hierarchy, you basically give them a shortcut that they can use. It's a way of telling them this hierarchy is really important to how we analyze our data. It's something that we expect you to use often. Otherwise, if you stick with just implicit hierarchies, you're sort of leaving them to figure this all out on their own. With an explicit hierarchy, on the other hand, you can save them a little bit of time and trouble. As I mentioned, there are several different flavors of slicers in Power BI. Slicers look differently and function differently if they're being used to filter numeric data versus date or time data versus text data. So we will explore these different variations of slicers later in the course. This video just serves as an introduction to basic slicer functionality, and you'll get many more opportunities to learn about them as we go along. By this point, I hope you feel more comfortable with where things are located in Power BI Desktop, and you have a better idea of how to create visuals with data and format the visuals to make them look the way you want. Let's ramp up the complexity now by adding more data to our U.S. states data model. Specifically, let's add some yearly population data for each state in a new table and see what challenges that presents for us. To begin, let's go to our Get Data menu on the Home tab of our ribbon and once again select Text/CSV. When the file picker appears, select the file from our Week 1 exercise files that is named U.S. States Population by Year. Once again, the preview window will open so we can get a look at the data in this file. Let's go ahead and hit that Transform Data button to open PowerQuery so we can take a closer look at the data that we're bringing in. Straight away, we can see that this data is bigger and more complicated than what we worked with before. In our rows, we have years starting at 1900 and ending at 2015. In our columns, we have each state's population figures. So if we focus on the AZ column, which is the state of Arizona, and scroll down, we get a chronological look at the population growth for the U.S. state of Arizona. Let's actually load this data straight into our data model and see what this would be like to work with in Power BI. Once the data load is finished, let's check out our data view and click on the U.S. states population by year table. Now we can see our table with all of its rows and columns. Make a note of how the states of Alaska and Hawaii don't have any population data prior to 1950. Now let's move to the model view, where we can scroll through all of the columns in our new table. There should be 52 total, one column for the year, and one column for each of the 50 states, plus the District of Columbia. Now hopefully you can already see a problem with this. With each state having a separate column in the data model, how are we supposed to visualize this information in our report? Supposing we want to create a line chart that shows population growth over time, we would probably need to manually add each of these columns to the chart. Not only would that be incredibly tedious, but it's also inefficient for our data model because it would need to run calculations against 51 different columns to figure out our population totals. So the way we currently have this table loaded into our data model is absolutely the wrong way to build this data set. The better way to do this would be if we could somehow rotate the data 90 degrees so that all of our states are in their own single column and the population totals are in their own single column. In other words, instead of having a short, wide table, we need to transform this into a tall, skinny table, where each combination of state and year is its own row. Now, those of you who are experienced in writing SQL queries against relational databases can probably already tell where I'm going with this. We're going to unpivot this table. And thankfully, Power BI has a quick and easy way to accomplish this. Let's go back to the report view and then click the Transform Data button to take us back into the PowerQuery editor. Then, let's go to our population table, select the year column, and then right-click to show our menu of options. Then find the option near the bottom that says Unpivot Other Columns. Select this and let's watch PowerQuery work its magic. It's going to essentially rotate our columns 90 degrees, putting all of our state abbreviations in one column called Attribute, and then putting the population figures in another column named Value. This kind of data structure is known as an attribute value pair, also sometimes referred to as a key value pair or a name value pair, something that experienced programmers and data engineers should be familiar with. So our unpivot transformation works by setting a pivot point, in this case the year column, and then translating the other columns in our table into this attribute value pair structure that you see here. The companion to unpivot is, you guessed it, pivot. In PowerQuery, you can pivot and unpivot columns as needed. To demonstrate, if we select our new attribute column, then go to the Transform tab and select the Pivot Column button, we get a small pop-up window that asks us how we want to pivot our data. It asks us to supply a values column, which is where the cell values will come from in our new pivoted structure. And you probably already guessed that we should use our new value column to accomplish this. Then we click OK. PowerQuery pivots the data back into the structure we originally had, translating our attributes back into columns and our values back into, well, values. Data that we get from file data sources like CSV and Excel files are often structured like this because inside of a spreadsheet, when looking at the data with the human eye, it's easier to see and interpret data in this way. Like earlier when we just scrolled down while looking at Arizona's population figures. However, this structure in Power BI is incredibly inefficient and inconvenient to work with because it creates too many columns that we need to manipulate. So we need to use the unpivot function to transform the original data into a format that makes our jobs easier when we're writing calculations and building visualizations in Power BI Desktop. Another cool feature of the PowerQuery recipe panel is that you can click through each step in the recipe to replay all of the transformations you've made to the data. So if we start at step 1, we can see the data in its original state. Then click on step 2 to see how we promoted the first row of data into our column headers. Then in step 3, PowerQuery scanned the data and determined that all of our columns contain integers, so it converted all of them to the integer or whole number data type. Then in step 4, we came along and unpivoted the columns. Then, in step 5, we pivoted them right back. This ability to play through all of your transformations is a really great feature in PowerQuery, especially if something ever breaks in your recipe and you need to trace through the steps to find the one where the error first occurs so you can fix it. So, that's pivoting and unpivoting in PowerQuery. Let's finish our query by first deleting the pivoted column step we just created, because that was just for demonstration purposes. Then let's rename the 2 new columns from our unpivoted data. Let's rename attribute to abbreviation, so it matches the abbreviation column from our first table, our states table. Then let's rename value to state population. And then let's shorten our table title by renaming it to just states population. And finally, let's do one more thing to reduce the amount of data we're working with. Remember from earlier that the states of Hawaii and Alaska don't have any population data prior to 1950. To keep our visualizations consistent for all of the states we're working with, let's make the decision that we should remove all years prior to 1950 from our dataset. This way, for all of our states, we have the same number of years, and we have a common and consistent starting point for our analysis of their populations. To do this, go to our year column and click the small button on the right edge. This opens a menu of options for sorting and filtering the data in the column, and we can see a scrollable list of all the values in the column starting at 1900. If the list is not complete, you should see a small Q at the bottom that says List may be incomplete, and this Load More button next to it will populate the rest of the list. You can see that this looks nearly identical to the filtering menu in Microsoft Excel. Let's go to the option labeled Number Filters, and select the option for greater than or equal to. This opens another small window where we can tell PowerQuery how we want to filter the data, and we're going to tell it to keep rows where the year is greater than or equal to 1950. Notice how there is a basic view and an advanced view for this feature, and we could potentially use the advanced view to create some more complex filtering logic. We don't need to do that here, so we'll just use the basic view and click OK to tell PowerQuery to only return rows where the year is greater than or equal to 1950. Before we return to Power BI Desktop, take a moment to open the Advanced Editor in PowerQuery and review the PowerQuery M code that we've generated in this video. Lines 1 through 4 are largely the same as our first query for the states table, but check out line 5 where we unpivoted the columns using this table.unpivotOtherColumn function. It's a pretty simple formula really, where we just tell it that the year column is our pivot point, and then we name the new columns where the unpivoted data should go. Next, on line 6, we renamed our columns, and on line 7, we used the table.selectRows function to tell PowerQuery to only return years greater than or equal to 1950. If you want to become an excellent Power BI developer, and especially if you want to earn a Power BI certification, you should get in the habit of reviewing your PowerQuery M code in the Advanced Editor and analyze the different functions that are being used. You will be asked about PowerQuery M functions in the Power BI Analyst Certification exam from Microsoft. To give you a deeper understanding of these functions, I will include links below our videos to some websites that contain documentation about the various PowerQuery functions we're using. Questions from the documentation may show up in your comprehension questions at the end of our units, so be sure to review them. Okay, in our next video, we'll load the unpivoted data into Power BI Desktop and continue our work, so stay tuned. Now that we've unpivoted our state population data into a format that is more suitable for Power BI development, let's hit the Close and Apply button to exit PowerQuery and return to Power BI Desktop. Once the new data loads, let's do what we always do and go to the Data view to take a look at it. Looking at our new states population table, we see our 3 columns: year, abbreviation, and state population, and the very bottom of the data view tells us that we have 3,336 rows in this table. Now let's go to the model view, and things should look a little different here. We still have 2 tables like we did before we unpivoted our data, but you should now see a stepped line that is connecting the states table to the states population table. If we hover over that line in the model view, the abbreviation column in each table will become highlighted. This line between the tables symbolizes that Power BI has created a relationship between these tables in our data model. The columns being highlighted tell us that the relationship is based on the abbreviation column in each table. When we loaded our new data into Power BI Desktop, it automatically detected that we have 2 columns in 2 separate tables with the same name, abbreviation, and it attempted to use those columns to create a relationship between the tables. Creating relationships in the model view is another hugely important aspect of data modeling in Power BI. As you will see throughout this course, you are often going to find yourself in a situation where you will be asked to report on data across multiple tables. Maybe those tables come from different data sources like the ones we're working with, or maybe they come from the same data source like a SQL database or SQL database, but from different tables. The ability to create relationships in your data model allows you to bridge the gap, so to speak, between these tables. Furthermore, creating relationships allows you to report on data that might have different granularities. Put simply, data granularity is how we measure the level of detail in our tables. For example, our states table contains one row per U.S. state. Each row in this table contains information about a single U.S. state and only that one U.S. state. When describing that table, we would say to ourselves, the grain of this table is one row per state. In contrast, our state's population table contains multiple rows per U.S. state. Each row contains a U.S. state, the year of its population total, and the value of its population total. So, when describing the state's population table, we would say the grain of this table is one row per state per year. By saying these things, we affirm what level of detail exists in each table. Our states table describes each state and its attributes, but the state's population table has a more fine-grained level of detail in that it describes each state's population totals broken down by the year. Understanding granularities is another key part of understanding table relationships in your Power BI model, because if we go back and examine the stepped line between our two tables in the model view, you'll notice that there are three small icons along the line. On the side of the states table, there is a small number 1. On the side of the states population table, there is an asterisk. And between both sides, there is a small arrow that points in the direction of our states population table. These icons symbolize the cardinality of the relationship that Power BI has created here. A relationship's cardinality expresses the way two tables are related to each other. And because tables can have different granularities when we connect them together, there exist 4 different cardinalities we can use in Power BI. There's a one-to-many cardinality, then there's many-to-one, which is exactly the same as a one-to-many, but with the perspective flipped. Then there is a one-to-one cardinality, which is when we connect two tables that have the same cardinality. And finally, there's a many-to-many cardinality, a more advanced data modeling technique in which the two tables may have the same or a different granularity, but both columns in the relationship can contain duplicate values. This is usually reserved for very complex modeling scenarios. If we examine our relationship again here in the modeling view, the 1 icon next to our states table symbolizes the one side of the relationship, while the asterisk next to our states population table symbolizes the many side of the relationship. And recall that our states table has a granularity of 1 row per state, while our states population table has a granularity of many rows per state. So the cardinality that is being expressed here in our relationship is a one-to-many relationship, or a many-to-one relationship, depending on how you look at it. The one-to-many or many-to-one relationship is the most common type of relationship you will see in Power BI. For simplicity's sake, from now on, I'm just going to refer to it as a one-to-many relationship. If we had a one-to-one cardinality, that would mean we have two tables that each contain 1 row per state, so they would have identical granularities. This would be represented by the number 1 icon being present on both ends of the line between our tables. And if we had a many-to-many cardinality, that would be represented by asterisks on both ends of the line. So what about this arrow in the middle that points from the states table to the states population table? This indicates what is known as the cross-filter direction. When you create relationships like this in Power BI, you are able to send filtering commands from one table to the other. That means if we filter on the state of Montana in our states table, that filter will travel down this line in the direction of the arrow to the states population table, and will then filter the data in that table using our relationship. In our next video, you will see this principle in action for the first time. There are 2 types of cross-filter directions. Single, which is represented by a single arrow heading in one direction, and both, which is also known as a bidirectional filter. Bidirectional filtering is symbolized by 2 arrows that sit back to back here and point in opposite directions along the line of the relationship. Bidirectional filtering is automatically applied on one-to-one and many-to-many relationships. However, single direction filtering is always the default for one-to-many and many-to-one relationships because it is generally assumed by the vast majority of professional data modelers that the table on the one side of the relationship will always be filtering the table on the many side of the relationship. It is possible to override that default and add bidirectional filtering to a one-to-many or many-to-one relationship, but it is not advisable to do so for two reasons. First, bidirectional filtering can degrade the performance of your report, and two, it can even cause issues with the results that our DAX calculations return. There are certain cases where it might be useful, and I'll link an article from Microsoft below this video that describes some of those scenarios. And we may even encounter some of those scenarios later in this course, but generally we should try to avoid bidirectional filtering whenever possible. The last thing I'll point out is that all of this information is also presented in a window called the Relationship Editor, which you can open by clicking this button on the Properties panel when you've selected the relationship in the model. You see Open Relationship Editor over here on the right. This window shows us a preview of the data in each table, and the highlighted column in each table is the column that forms the basis for the relationship. We can change the column that forms the basis of the relationship, or we can attempt to change the cardinality and the cross-filter direction using these two menus down below. We can also make the relationship inactive, which is helpful for complex modeling scenarios that we might cover later in this course. Now, everything that I talked about is all going to seem really abstract at first if you're not familiar with relational data structures. Those of us who have been working in SQL databases our whole careers, like me, this kind of stuff is practically part of our DNA by this point. We see table relationship diagrams like this one in our sleep. But I will also say that table relationships can be one of the most difficult parts of building effective data models in Power BI, even for experienced data modelers like me, and especially for novices. Those kinds of table relationships, those are the ones we just don't see in our sleep, but we have legitimate nightmares about them. And as we get further into this course, we'll wrestle with a few challenges that center on table relationships, but hopefully nothing too complex that will send you running for the exits and leaving this course behind. I'm going to try to keep this at a beginner's level still, but still presenting some challenges along the way. So, now that we have our relationship created, our next few videos will look at how we can visualize data that exists in two separate tables. This is where Power BI really starts to get fun, so I hope you're excited. To begin using our new population data, which has been added to our data model through our one-to-many relationship from the states table to the population table, we're going to introduce calculated columns in Power BI. Calculated columns are created in your data model through writing DAX formulas, which makes them seem like measures at first, but there are some crucial differences that we're going to discuss. First, let's create the calculated column on our states table. We will transition to the data view, and then go to the states table, and then we'll click the button on the ribbon for the new column, which can be found in multiple places on our ribbon, or we could just right-click on the table and select new column. This will open the DAX formula bar just below the ribbon, and we're going to type in a relatively simple formula. We'll title it 2015 population equals, and then I'm going to use Shift-Enter to go down a line. We're going to start with the calculate function, and then an open parenthesis, and Shift-Enter to go down again, and then sum, and then we're going to find our states population column, which can be seen in this menu here, and I'm going to hit Tab to auto-populate that. Then we will use a close parenthesis, then a column, Shift-Enter to go down another line, and then I'm going to start typing and find our year column, use Tab to populate that, and then hit equals 2015, and then I'm going to hit Shift-Enter one more time to go down a line, and close parenthesis to end our formula. Before we commit this formula, let's examine what it's doing. First, we invoke a new DAX function known as calculate. Calculate is one of the most important and most commonly used functions in the entire DAX language because it can apply filters to DAX calculations. All DAX functions consist of at least one parameter. Another word for a parameter that you will sometimes hear is an argument, and I might use them interchangeably. Just know that they are synonymous. DAX parameters or arguments can be required or optional depending on the DAX function that we're talking about. And each parameter is separated from the others around it by using commas within the formula. So, using our calculate function as an example, it consists of two parameters. The first one, the expression parameter, is required. This is the DAX expression or calculation that we are calculating. Then there's a comma, and we move to the second parameter. The second parameter is optional, and it's called the filter parameter. We use the filter parameter in the calculate function to tell Power BI how we want to filter the data to recalculate our expression. In this particular formula, our expression parameter is the sum function on line 3 of our formula. This is summing the values from our state population column. When we wrap that sum function inside of the calculate function, we can then go to our next parameter, the filter parameter, which is where we can enter an expression to filter the data in some way. The filter expression is looking for some logic that can return either a true or false value. Remember that true and false values are also known as logical or Boolean values. In other words, this simple line here is interrogating each row in our population table to determine if the year is equal to 2015. If the year is equal to 2015, this expression will return a true value. If it is any value other than 2015, it will return false. So at the most fundamental level, all the calculate function does is recalculate something where these conditions are true. The result is that this formula is going to reach down from our states table to the states population table, using that single direction filter that we discussed in our last video to move along that relationship line. Then it's going to filter the data in the population table to only those rows where the year is 2015, and then it will sum the population column in that table, and that will be our result. Next, let's commit the formula and see what happens. A new column is added to our states table called 2015 population, and for each state in our table, it contains the 2015 population value that we calculated from our population table. Let's add our new calculated column to the table visual on our report canvas. I'm going to start by resizing some of these visuals to make a little bit more room on the report canvas. And then I'm going to resize the table. And now let's add 2015 population. Then let's click on the column header to sort our population in descending order so we can show our most populous U.S. states at the top of the table and our least populous U.S. states at the bottom. Next, let's format our column. A few videos ago, we discussed the Measure Tools tab on our ribbon, and if we select our 2015 population column from the Data panel, we can see that we also now have a Column Tools tab on the ribbon. On this tab, we will see a section for formatting, which tells us that the population column is formatted as a whole number. Now, if we want to add commas to our number so that we can separate thousands and millions in our report, we just need to click this little comma button in the formatting section, and Power BI has now reformatted this column with commas. And an important thing to know here is that this change will be implemented everywhere that you use this column. If you change how it is formatted on the Column Tools tab, you will see that change take place in every visual on every page of the report where that column is visible. The last thing we can do is change how the column is aggregated on our table. So if we select the table visual and then open the OnObject editor for our table and select the 2015 population column, a small menu appears to the side where we can either change the field itself or we can just change how it's being aggregated. Let's change the aggregation to a sum to see the change that this creates in our table. And this may require us to resort our table columns, so be prepared for that. You'll notice now that the amounts for each row in our table are the same, but now our state populations are being summed, and the total for the entire population of all states is now visible in our totals row at the bottom of the table. And if we change that aggregation from a sum to a median, the total row now tells us the median population across all U.S. states. So, with this video, we've demonstrated one of the many uses of DAX in Power BI, to add calculated columns to our data set. Not only that, but how to add a calculated column that calculates data on one table from a totally different table. And this is usually the point where astute beginners begin to ask the question, what exactly is the difference in DAX between calculated columns and measures? For the answer to that, I will see you in our next video where we will explore those distinctions in depth. Some of you may be confused about the difference between calculated columns and measures at this point. I mean, they both use DAX, right? And just a few videos ago, we used DAX to add a measure to our data model that counts up the number of states in the states table. But creating that measure did not add a column to our states table. In contrast, when we used DAX to create a calculated column, that actually did add a column to our states table. And therein lies one of the chief differences between measures in DAX and calculated columns in DAX. These differences are the subject of this video. Now, remember that measures are little more than formulas that exist as metadata in our model. They are dynamically calculated in your report based on whatever context you add them to, whether that's a matrix or a chart or a map. Also remember that measures do not need to be bound to any particular table in your model, which is why we typically add them to a measure table to group them all together in one place. Calculated columns, by contrast, are not dynamically calculated in the report. They are calculated only when we refresh our data set from the data source. Not only that, but calculated columns are absolutely bound to a particular table in our model, where the calculation we define is going to be evaluated for each row in that table. In our last video, we set out to calculate the 2015 population for each U.S. state, so we added the column to our states table, and the DAX formula that we wrote retrieves the 2015 population for each row in that table. So you can see that calculated columns depend on tables by their very nature, whereas measures are not bound by the same context limitations. That's why measures can exist on any table, and they will function the same wherever you choose to locate them, anywhere in your data model. Now, not only do calculated columns need to be bound to a particular table, but they actually add data to the table when they are calculated. So, whereas measures are just formulas that exist as metadata in our model, and they are dynamically calculated whenever we interact with the report, the results of calculated columns are physically stored in our data model. When data is physically stored in a structure like this after being queried or calculated, this is known as data persistence. And the results of calculated columns are persisted in our table, making them an indelible part of our data set. This means calculated columns can sometimes be faster than measures, performance-wise, but it also means they take up space, making your data set larger. So here's a summary of some of the key differences between measures and calculated columns. Be sure to study these closely, and I'll also provide some additional reading below this video that you should check out. Pay special attention to where the authors talk about the evaluation context. Now that we've explained the key distinctions between measures and calculated columns, some of you may be asking the question, if calculated columns persist in our data model, can we also create calculated columns using our transformations in PowerQuery? And the answer is absolutely yes. You can create new columns in your data model using PowerQuery, although you won't be doing it with DAX. You'll be doing it with PowerQuery M, and it will probably take a little more work to accomplish. One of the nice things about DAX is the ability to take advantage of table relationships, like we did in our last video, so you may find it easier to just perform this operation in DAX through a calculated column. I think it's more streamlined that way, but just know that whichever method you choose, the end result will be the same. You'll be adding a column to the states table. In our next series of videos, we're going to wrap up our first report in Power BI by adding some interesting new interactive features, styling the report to make it look nice and clean, and teaching a few key best practices that you should know for the rest of this course. Okay, our last few videos were pretty dense. We discussed the complex topic of table relationships in data modeling with terms like granularity and cardinality, and one-to-many versus many-to-one, versus one-to-one, and versus many-to-many. And we did some basic stuff with DAX and learned about the distinctions between measures and calculated columns. It's important for you to learn all of that content in week 1, but let's try to finish this week with something really fun. Let's make this report look polished and professional, and then let's explore the data a little bit before we wrap up. So far, we've just been adding visuals onto a blank white canvas. Sure, we've done some formatting changes here and there, and we've created a nice cohesive color theme where we have colors that are being shared consistently by our census regions across all of our visuals. However, our visuals don't really have any clearly discernible borders or boundaries between them. We have a blank page, and then all of a sudden we just kind of have visuals lying out here in the middle of the white space. Our goal should be to more clearly separate the visuals from each other in this situation, because this makes it easier for our brains to process the fact that it's moving between different sets of information. There are several ways to do this. We could outline each visual with a black border like so. Go to our Format settings, and then just go to Size and Style, and slap a visual border around it. And this is probably the most simple and direct approach. But Power BI gives us a lot of tools to make reports and dashboards that are more visually appealing than that. And I believe strongly that you shouldn't skip over the aesthetic aspects of data visualization. We shouldn't just do the bare minimum by dropping some charts onto a page and then calling it a day. Good visual design in Power BI means using the style elements that are available to us to make it easier for your audience to understand the data. And as we've seen, this can sometimes be aided by something as simple as color choice. And sometimes it can also be done by creating a sense of depth and separation between the various elements on our page. Let's explore some ways to accomplish this with our states report. Let's begin by giving our report canvas a subtle color. This will help create some visual distinction between the background of our report and all of the elements in the foreground of the report. To do this, we will right-click on an empty area of the canvas and say Format Canvas. Then we'll go to our Format panel where we can see a section called Canvas Background. Open this, and the first thing that you see is a color picker. Let's pick the lightest shade of gray from our list in the first column of colors, and then let's set the transparency to 0%. This is going to color the whole page in that light gray color, which immediately helps us visually distinguish our foreground elements because they all have white backgrounds. So now we can better tell where one visual begins and another one ends. This is a good start, but we can do better. Another way I like to increase the distinction between these visuals while also adding some interesting depth to my reports is by adding drop shadows to my visuals. Every visual has a set of size and style properties that you can change, which include the X and Y coordinates on the page where the visual is located, the background color, the border, and the shadow. To enable the drop shadows on our visuals, all we have to do is select each one, then go to the Format panel and turn on the Shadow property. This immediately gives each visual a subtle dark shadow behind it, and it gives them the appearance that they're floating above the page. Let's go through and do that for all of our visuals. Because our visuals have a white background, this just increases the visual contrast between them and the background of our report, making them stand out more from the page. The only thing you need to be careful of with drop shadows is putting enough distance between your visuals that their shadows don't obscure the visuals around them. So take a look at our slicer in the upper left corner as an example. In this case, our visuals aren't overlapping. They don't need to overlap. In our report, as it is now, the slicer sits above our map visual, and this is causing its drop shadow to actually overlap a little bit with the map visual, obscuring it. So just putting one visual with a drop shadow directly next to another visual could be enough to cast that shadow on the neighboring visual, like you see here. And that makes it look like you're not giving enough attention to detail about how your report looks. So I like to create space between my visuals to avoid these situations. When I create space between visuals, I like to keep that space as consistent as I can across the page. To help with this, on the View tab, I always enable the Snap to Grid option. You can turn on the grid lines as well, which will give you some nice little visual cues that you can use, but I rarely use the grid lines themselves. I just use the Snap to Grid option. Using Snap to Grid can help you align your visuals to each other more easily and keep their heights and widths consistent with each other. And when I'm using drop shadows, I generally place each visual 2 grid widths apart from its neighboring visuals. This helps prevent the drop shadows from getting in the way, and it also keeps the spacing consistent. So now watch as I go through and realign everything. Now that I'm done making those changes, the space between our visuals is consistent. The drop shadows don't appear to be overlapping anywhere, and we now have this overall effect that makes it seem like you're looking at a dashboard that is made up of these distinct widgets that are floating above the page. And this is an effect that I really like when I'm building Power BI reports. So now let's talk about the report theme. You may recall that on the View tab of our ribbon, there are a number of preset themes we can use in our report. Maybe you've already played with these between videos, but I'm still using the default Power BI theme here, and maybe I'd like to switch it to something that I like a little bit more than this. If I open up the Themes menu, there are several different ones I can choose from, including accessible themes that are more friendly to users who have color blindness. To change our report theme, all we need to do is select one of the themes from the list. I'm going to find and select the Classroom theme, which has some nice strong colors that I like. Now, right away, something is off. Our theme has been applied to our shape map and our bar chart, but our table cells are still using the original color scheme we picked out through conditional formatting. Not only that, but the background colors on our visuals have gone away so that they're actually gray, matching the background color of our report canvas. These are some things that we're going to need to fix in the next couple of minutes. First, let's start with the conditional formatting. Let's select our table, and then go to the formatting pane and find the Cell Elements section, find the Background Color section, and click on the FX button to open the conditional formatting window. And then let's go through and let's change each of the colors to match what they currently are in the new theme. We have blue for Midwest, dark blue for Northeast, gold for the South, and red for the West. Then click OK, and now our color scheme matches again. Next, let's go through each of our visuals and reset the background color property on all of them so we can restore that visual distinction that we had earlier. And the next thing I'm going to do is I'm going to create a little bit more distinction between our visuals by going to the canvas background settings that we were working with earlier, and I'm going to set the canvas background to a darker shade of gray. I like the way that looks. If you want to customize a theme, you can open the Themes menu again and then find the option to Customize Current Theme towards the bottom of the list. This lets you override the theme that you've chosen with your own settings. Furthermore, if we go back and open the menu again, you can export all of the metadata about the theme into a JSON file by clicking on the Save Current Theme option. This allows you to reuse this theme over and over again with other reports. So you can design your own custom theme using the wizard here in this menu, and then you can export that and use that over and over again in different reports throughout your organization. To do so, you can simply use the Browse for Themes button in this menu, and then find the JSON theme file on your computer, pick the one you want to import, and Power BI will import that and take care of the rest, automatically styling all of your visuals according to the theme file. You can also import themes from the Power BI Themes Gallery, which is also available through the menu. And there are some really creative and amazing themes in here, so I encourage you to use some of these throughout the course. Explore and download these and import them into your report, and use these on your own, or even design your own if you want to go for a more individualistic approach to styling your reports. Just try to import the theme before you start customizing any style elements in your report. If you import the theme after you've already done a bunch of customization using the Format panel, you may end up having to undo all of that customization in order to get the imported theme to look right. Okay, I'm pretty happy with the way this report looks. In our next video, we'll add another visualization to our report page, and then we'll spend some time exploring our report to look for some interesting stories in the data. There's one more visual I would like us to add to our report and examine, but first we need to clear some space on our page. Let's select the table visual, and then let's click and drag the bottom edge to resize it and make it smaller. We're going to make some room down here in the bottom right corner to fit our new visual. While I'm at it, I'm also going to go to my table settings and turn off the totals because we don't need it. Now, a few videos ago, we brought in 65 years worth of population data for each of our US states. But so far, all we've done with that data is create a single calculated column to retrieve each state's 2015 population. So, in this video, let's create a visual that helps us see which US states have been growing the most over the last 65 years. The visual I like for this exercise is called a ribbon chart. Let's add one to our report canvas by going to the Insert tab, then opening up the Visuals menu, finding Ribbon Chart, and clicking to add it to our canvas. Now, let's look at the settings by looking at our OnObject editor. We can see that we have both an X-axis and a Y-axis, as well as a legend. So let's go ahead and start adding data to the X and Y axes by going to, for our X-axis, the state population table, and add the year column. Then for our Y-axis, let's go to the state's population table and add the state population column. Let's also go to the Format panel and Size and Style, and let's add background to our ribbon. And let's go ahead and add that drop shadow too. Now, so far, when we look at our ribbon chart, it just looks like a standard column chart, right? But watch what happens when we go back to the editor and we scroll down to the legend and we add states to the legend. We go back and add our state name column right here. Suddenly, our visual is splitting the data by state, and it no longer looks like your boring everyday column chart. Now it looks really visually interesting. And to focus in on this visual a little bit closer, I'm going to employ something called focus mode in Power BI. This is a little icon in the upper right corner of each visual that looks like a couple of rectangles, one inside the other, and an arrow pointing towards the upper right corner. You can just use focus mode anytime you want, and this is going to actually open your visual in a full screen mode. And you can see there's a button in the upper left corner that when you click it will take you back to the report. So let's go back into focus mode now and take a closer look. A ribbon chart is similar to a standard stacked column chart in that it takes the values from our data and stacks them on top of each other. But it also moves the bars around based on how big they are. In other words, what a ribbon chart does that's different from a normal column chart is that it ranks the data. The biggest values are on top, while the smallest values are on the bottom. And as the ranking of a state changes over time, the state can move either up or down on the chart. Between each of the columns, there's also this sort of connective tissue, this lighter color that joins the years for each state, and that helps your eyes sort of follow that progression over time. This makes the ribbon chart into a very useful tool for visualizing how various states' populations have grown over time and how their rankings have changed over time. For example, California, shown in this green color, is currently the most populous state in the US, as evidenced by the fact that since 1963, it has maintained its position at the top of our ribbon chart. And we can see 1963 if we actually hover over that bar and get the tooltip. Prior to that, New York was actually the most populous state in the United States. But then it fell to second place, and then ultimately it fell to third place in 1994. And then finally, by the year 2015, it had gone all the way down to fourth place. Meanwhile, Texas, which you see in this gold color, started in sixth place in 1950, but has since moved up to second place over the same span of time. But the real story here is Florida. If we hover over Florida's data in 1950, we can see that back then they were ranked 20th. But now if we move all the way to 2015, Florida is now the third most populous state in the United States of America. One of the neat little features of the ribbon chart is that when you hover over that little connective tissue that I mentioned earlier, the gaps between the columns, it will summarize the change in these values from year to year in the tooltip. As an example, if I hover over this transition for Texas in the year 1994, we can see that it went from being the third most populous state to being the second most populous state. And there are several other more important pieces of information here. It displays both the 1993 and 1994 populations of Texas, as well as the sum of the population change from year to year, increasing by 341,000 people between those years, or a roughly 1.9% increase. Then it tells us that their 1993 rank, which was third, followed by their 1994 rank, which was second, was an increase of 1 in the rank change section. So the ribbon visual might be one of the only visuals in Power BI that gives you this capability to see rank changes and percentage changes automatically baked into the visualization. So it's a fantastic way to visualize rankings, especially rankings as they have changed over time. Let's now exit focus mode by clicking the Back to Report button and return to our report canvas. Let's now explore how the visuals interact with each other. Specifically, by selecting states from our map visual, we can see a little more clearly each of the stories in the data we just talked about. If we click on Texas, for instance, that state's data will become highlighted in our ribbon chart. And you can see that they were already really big in 1950, and they just got bigger. Then, if we switch to New York, they were the most populous state for a long time and have been steadily overtaken by California, then Texas, and most recently, Florida. Then, if we switch to neighboring Pennsylvania, we can also see how they have followed New York down, starting at third place in 1950, and then ultimately ending up in sixth place by 2015. Then we'll select Florida to once again highlight its meteoric rise from the middle of the pack after the Second World War to becoming one of the 3 most populous states today. And finally, another rapidly growing subject is Arizona, a state that is largely defined by its desert climate. And that might be a little bit hard to see because its color is gold, but if you look closely at the ribbon, you can still see it. But Arizona is a state that is largely defined by its desert climate, at least in the southern half of the state. The northern half actually has a lot of forests. But since the middle of the last century, Arizona has exploded in size, starting as the 38th most populous state in 1950 and then rapidly growing into the 14th most populous state by 2015. So hopefully you can see that there are some interesting stories hidden in our U.S. states data. Stories that show how some areas of the country are growing rapidly as people migrate to different areas. But this isn't the end of the story. Our data set only goes back to 2015. Since then, the COVID-19 pandemic had a noticeable effect on where Americans choose to live, as the transition to more remote work caused many people to leave states like California, which have a more expensive standard of living, and relocate to states like Idaho and Montana, where there are far fewer people and real estate is typically much cheaper. These developing patterns of people moving from more populous states to less populous ones are going to create large economic, political, social, and environmental changes in the United States that, so far, we can only try to predict. Hopefully, American leaders are looking closely at the data, maybe in a tool like Power BI, who knows, to try and figure out the best way to manage these population shifts. Let's take a few minutes now to discuss a key best practice in Power BI development, and that has to do with measures. There are actually two different types of measures in Power BI, explicit measures and implicit measures. Explicit measures are those measures that are defined using the DAX formula language. They are explicitly created by us with DAX using the data in our model, and they can be easily identified by the calculator icon that sits next to each measure's name on the data panel in Power BI Desktop. The obvious example from our work this week is the states measure that we created, which is used in some of our visuals. Implicit measures, on the other hand, are created by taking columns from our data model and simply adding them to visuals, and then assigning an aggregation to those columns. Any type of column can be used to create an explicit measure, depending on how you're trying to aggregate the data. For instance, if I use a numeric column, like population, to create an implicit measure, I can use aggregations like sum, average, minimum, maximum, median, and standard deviation. On the other hand, if I use a text column like our state abbreviations to create an implicit measure, I'm limited to just counting distinct values or counting non-distinct values. If I use a date column, I can aggregate by the earliest date in the column or the latest date in the column. Here are some examples of implicit measures that we created in our previous videos. When we first added data to our bar chart to get a count of states, we added a text column to the x-axis of the chart and told it to use a count aggregation. This was our first implicit measure. When we created the 2015 population calculated column and added it to our table visual, and when we added the state population column from our population table to the ribbon chart in our last video and told it to use the sum aggregation. Although using an implicit measure in each of these situations gave us accurate results, it is considered best practice to use explicit measures whenever possible in Power BI. Using implicit measures for your visualizations is discouraged by the vast majority of Power BI experts, and we're going to talk about why in this video. First of all, I'll point out something that's hopefully obvious. Creating explicit measures requires you to use DAX, and as I've said before, DAX is a fundamental part of Power BI. Remember that DAX isn't just how we create measures, it's also the query language that Power BI uses to retrieve data from the underlying data set to the report. So, by writing explicit measures, you force yourself to learn DAX, and the more you use DAX, the quicker you will acquire a better understanding of how Power BI works behind the scenes. Second, explicit measures can be reused in other explicit measures. This means you can define a measure one time, such as the sum of all transactions in a table, and then you can reference that measure to create more measures, such as the sum of all credit transactions, or the sum of all debit transactions, or the sum of all credit transactions that are classified as revenue, or the sum of all credit transactions that are classified as revenue that were posted to last year's ledger or this year's ledger, and so on. This reusability saves you from having to rewrite the same calculation multiple times. Third, explicit measures are way more flexible than implicit measures. When you add an implicit measure to a visual, as we have seen, you can choose from a handful of different ways to aggregate that data. You can do a count or a distinct count, you can sum it, average it, find the minimum or maximum, and so forth. But those are all of your options. When using implicit measures, you are very limited in the type of analysis that you can do. Explicit measures, however, benefit from using DAX, which has hundreds of different functions that you can use when building formulas. And this might seem daunting, but as you gain more experience with DAX, this actually becomes a liberating aspect of using explicit measures over implicit measures. With explicit measures in DAX, almost anything is possible, but with implicit measures, you can really only do about 10 things. For example, when we get further into this course and begin looking at time series data, I'll show you how DAX makes it easy to perform year-to-date and year-over-year analysis in Power BI with just a few additional lines of code. And that is impossible to do with implicit measures unless you engage in some very convoluted and unnecessary data preparation in PowerQuery. I think the flexibility of DAX creates the biggest advantage of using explicit measures. Fourth and finally, explicit measures can be used to create dynamic text labels that you can add to your reports, such as in your chart titles, which is yet another great feature that I will demonstrate in this course. Another limitation of implicit measures is that they can't be used when connecting Microsoft Excel to a Power BI dataset. This is a fantastic feature in the Power BI ecosystem known as Analyze in Excel, and it connects an Excel workbook directly to a Power BI dataset through what's known as a live connection, and allows you to build a pivot table in Excel using the data that's in your Power BI dataset. This feature is incredibly useful for performing ad hoc analysis of the dataset, or if your users just prefer using Excel. This is actually a feature that our finance team here at Davidson uses frequently. We have a Power BI tabular model that they can connect to from several different Excel reports, and then they use those Excel reports to keep track of the college's operating expenditures and fund balances. It's an incredibly powerful capability. However, implicit measures cannot be added to these Excel pivot tables, while explicit measures can. So, if you're planning to connect Excel to Power BI, you need to build explicit measures into your data model. Interestingly, one area where you will not see any difference between implicit measures and explicit measures is in performance. An implicit measure is still a measure, it's just an implied measure that Power BI is calculating based on how you added it to a visual. So whether you create an explicit measure that sums our population column and you add it to a chart, or you just drop the implicit measure onto that same chart, Power BI is doing roughly the same calculation in both scenarios, and it's highly unlikely that you would see any performance benefit from choosing one option over the other. So hopefully you can see that there is literally zero downside to using DAX to create explicit measures, other than, well, needing to learn DAX. Everything else is 100% upside. Explicit measures are more flexible, and they're reusable. Case closed. To me, it's like the difference between ordering a cheeseburger from a fast food restaurant versus making the cheeseburger myself. Sure, the fast food restaurant is quick and easy, but my options are limited and it's probably going to be bad for me. Whereas if I cook my own burger, and here I go with that cooking metaphor again, but if I cook my own burger, it will require more thought and effort from me, but I can also make the burger however I want. There are thousands of possibilities. And that's what it's like to use explicit measures in DAX. It takes more effort, but you have much more flexibility, and it's probably better for you. So I'll post a couple of articles below the video that should reinforce the difference between explicit and implicit measures. Do your best to learn the distinction well, because while you probably won't see this question come up on the Power BI certification exam, it very well could come up in a job interview. Asking job candidates to explain these differences is one of my favorite ways to determine if someone really knows Power BI and if they're really committed to doing Power BI the right way using best practices. Okay, we're almost at the end of our Week 1 lessons. How about we do something else fun and add a little more visual flair to our report? The ribbon chart we created a few units ago is really awesome for looking at each state's population growth as part of a larger context. We can see how their population rankings have changed over time. However, what if we want to get a quick glimpse of each state individually? Is there a way we can just peek at one state's data without taking up more space on our report page, which is already full of content? The method that I like to use for this is known as a Tooltip page, and this video will show you how to build one for your report. First, before we do anything else, let's recall what we said in our last video about creating explicit measures. And remember that we don't currently have an explicit measure for our population. We should create one of those. So let's go to our data panel. Let's select our measure table and expand it, and then let's click the new measure button on our ribbon and write a simple measure. We're going to say population equals sum of the state population column. Then close parentheses and hit enter to commit the formula. Let's now format it as a whole number with commas, and then let's go to our ribbon chart and open the onObject editor and replace our implicit measure here that's hanging out on the y-axis with our new explicit measure from our measures table. And now this visual, even though it doesn't look any different, is conforming to Power BI best practices because it's using our explicit measure, just like we talked about. Yay! Okay, now we can move on to building our tooltip page. Start by adding a new page to our report. You can do this by going to the bottom of the report view and clicking the green button with the plus symbol next to page 1. Or you can go to the Insert tab on the ribbon, open the New Page option, and select Blank Page. When our new page opens, notice how it's now visible along the pages at the bottom of the report view, similar to how sheets are arranged as tabs inside of Microsoft Excel. To rename our pages, we can simply double-click each one, or we can right-click and select Rename Page. I'm going to rename page 1 as Overview by double-clicking on it, and then I'm going to rename page 2 as Pop.Tooltip. On the blank new page we just created, right-click on the empty canvas and select Format Canvas. Then find the Canvas Settings section on our Format panel on the far right side of the application, and find the option for Type. This is a drop-down menu that lets you customize the report canvas size and display ratio. It defaults to the 16:9 aspect ratio, which is common for widescreen monitors, but you have other options to choose from here, including one that says Tooltip. So let's select that one and watch as your page gets shrunk down to a fraction of its original size. If you think this is too small and you can't see what you're doing, don't worry. You can switch to the Custom option, which will allow you to select a specific pixel height and width for your page. So I'm going to bump mine out to a width of 400 pixels, but I'm going to keep my height the same. Next, let's add a visual to the page. Now, as you can probably guess, we only have room on this page for one visual, and our goal is to look at each individual state's population growth over time. So the best visual for this is probably going to be a line chart or an area chart. So let's select one of those from our Insert tab, and then let's click and drag and resize it so that it takes up the entire space of our tooltip page. Next, on our line chart or area chart, let's use the onObject editor to put the year from our population table on the x-axis. And then let's add our population measure to the y-axis. Now, you're probably going to look at this and say, okay, this shows over 320 million people for the entire United States. But you said we would be building a chart that only shows one state at a time. Pete, you're a bad teacher. But hopefully you're not saying that last part, because I promise this totally works. As we're looking at the chart now, it's not being filtered. But the way tooltip pages work is that when you hover over another visual, like our shape map, if it sees that your mouse is hovered over, for example, the state of California, it will send that little nugget of information to our tooltip page as a filter. and tell it to filter its data on the state of California. So what we're lacking here is just some filter context, and we need to set it up on one of our visuals on the overview page. So let's head back to the overview page, and then let's select our shape map visual. Then open up the Format panel and find the section under the Properties tab named Tooltips. Click to toggle it on if it isn't toggled on already, and then use the first drop-down menu to change the type of tooltip from default to report page, and then use the next drop-down menu, which is called Page, to select our pop.tooltip report page. Now let's go back to our shape map and let's start hovering over some states to see the results. Pretty cool, huh? So there are just a couple of things that we could do to improve this. First, let's try to find a way to add each state's name to the tooltip page, because right now it's just giving us this little generic title in light gray that says population by year. So let's return to the tooltip page. Let's select our line chart visual, and then let's go to the Format panel, find the title section, and here we see our title. First, let's darken the color a little bit by changing it to black, and then let's make that a bold font. Then we can override this static title that says population by year by clicking the tiny little FX button next to the title box. This is going to open up a new window where we can tell Power BI what data we want to display in the chart title. We're going to tell it to use a field value, and in particular, we're going to tell it to use the first state from the states table. So open up your states table using this drop-down menu and select our state name column. Then close the window by clicking OK. And initially it's going to say Alabama because Alabama is alphabetically the first state in our states table. But if we return to the overview page and hover over our map visual again, starting with, say, the map of North Dakota, then now we can see North Dakota is our chart title. And we can move around to Montana, Idaho, Utah, Wyoming, Colorado, and watch as it changes depending on which state we're looking at. Now, what if we want to give a little more detail in our tooltip title? Well, we can use DAX for that. Let's select our measure table on the data panel, and then let's create a new measure. And I want you to type this in with me. We're going to call this tooltip title. We're going to use Control-Enter to go down a line. We're going to enter a selected value measure, followed by an open parenthesis. And then we're going to add our state's name column, which is state's state right here. Close parenthesis, ampersand, years. Inside of quotation marks, we'll have this little years thing right here. Go down another line, tab over, and we're going to use the min function now in an open parenthesis and return our year column from the state's population table. Close parenthesis, ampersand. Then we're going to do another hyphen inside of quotation marks. Then come down another line, ampersand max. Find our year column one more time. Close parenthesis, and we're done. Hit enter when you want to commit the formula. But before I commit this, let's take a moment to explain what we're doing. The name of our new explicit measure will be tooltip title. It begins by using this function on line 2 called selected value, which is used to return a single value from a column in your dataset. In this case, we're feeding it the name of each state from our states table. Next, we close the parenthesis on that selected value function and follow that up with an ampersand, and then some text inside of quotation marks. Anything inside quotation marks like this is just treated as static text. And the ampersand symbols to the left and right of that text are how we can combine that text with the results of other functions in DAX. So immediately after that, we use the min function on line 3 to return the minimum possible year from our population table. Then we have 2 more ampersands surrounding a hyphen or dash symbol inside of more quotation marks. And then below that on line 4, we use the max function to return the maximum possible year from our population table. The goal here is to use DAX functions to dynamically generate a title for our chart, and we can supplement those functions with static text. So now let's commit our new measure, and then let's go to our Pop Tooltip page and add this as our chart title. Select the line chart, go to the Format panel, go to the Title section, and then click the FX button to reopen our window from earlier. Then let's replace the original field value that we had here, first state, with our new tooltip title and click OK. Now let's go back to the overview page and start hovering on our shape map. For instance, if we hover over North Carolina, we can see that the tooltip now displays a title that says North Carolina, years 1950 to 2015. Using DAX measures to create dynamic chart titles is something that we're going to return to throughout this course. We can also add this tooltip to our table visual by selecting it, going to Properties, turning on the tooltips, telling it to use a report page tooltip, and our Pop Tooltip report page, and then if we hover over any row in our table, we again get our tooltip. So the tooltip is visible on multiple visuals in our report page. Okay, that's how you can create an interactive tooltip page in Power BI. This is a really useful technique when you want to give your users just a quick glimpse into some underlying data. You can even embed images in these tooltip pages, so you can create an interactive roster of employees in a department or students in a course, and then when you hover over a student's name in the overview, you can actually see their picture and some details about each person. This is a really useful technique in Power BI, so I hope you found this to be a fun and engaging video. I'll see you in the next one. In this video, I'll introduce the Week 1 final exercise. The first 3 weeks of our course each have a final exercise that gives you the opportunity to work on a small project on your own, synthesizing the lessons that you learned through our video lessons and additional reading. The final week of our course will use a larger capstone project, which you will also complete on your own. Since this is just the first week, we will keep the exercise relatively short and simple. We're going to add some more features to our U.S. States report with the goal of turning our existing report into a fully interactive data exploration tool that allows us to analyze population growth rates during different time periods. We won't add any more data with PowerQuery. Instead, we'll rely on the data that we've already loaded, but we'll focus on using DAX to create measures on top of that data. And we'll add those measures to the report, along with a slicer, and we'll use those tools together to interactively explore the data. You'll be given a set of quiz questions to answer, which will require you to find specific answers within our data set using your Power BI report. And other questions in the quiz will test the knowledge that you've gained from the previous videos this week. There is a video after the quiz questions where I will walk you through how I would solve this particular exercise, but I encourage you to challenge yourself to do it on your own first, and don't be afraid to fail. This exercise is designed to test your ability to recall the lessons that you learned in Week 1 and think independently about how to apply those lessons to this exercise. Remember, our goal is to create a fully interactive report to analyze population growth rates during different time periods. That means your report should be able to quickly answer questions such as, what was the population growth rate in the state of California from the year 1965 to the year 1970? Or, which state had the highest growth rate from the year 1990 to the year 2000? Using nothing but the visuals on your report page, you should be able to rapidly answer these kinds of questions. I'll give you some hints about how to solve this before you begin. First, here's a basic math refresher. The formula to calculate the growth rate between two periods is the difference between the new value and the old value divided by the old value. In other words, if x is our old population value and y is our new population value, the population growth rate is calculated by finding x minus y, then dividing that result by y. The result is a growth rate expressed as a percentage. Second, to calculate that growth rate, you will need to use the following DAX functions: calculate, min, max, and a new one which we haven't used yet, which is divide. Calculate can be used in combination with min and max to determine the beginning year of your analysis and the ending year. Below this video, I'll include links to documentation that will describe what each of these functions does. Also, make note of the fact that you can format data as percentages in Power BI, and you can control the number of decimal places in your percentages. See if you can figure out how to do that in this exercise. Third, you should not create any calculated columns to finish this exercise. First of all, calculated columns aren't dynamic enough to create the kind of interactivity this exercise requires. Instead, you will create measures. It is possible to complete this exercise by adding only a single measure to your model, but you probably won't know how to do that if this is your first time working with DAX. Instead, you should plan on creating multiple measures, and remember that measures are reusable in other measures. Do your best to apply that principle in this exercise. Fourth, to answer the questions in this quiz, you should only need a table visual and a slicer visual. Use the slicer to control how many years of data are visible in the table. With the slicer, you should be able to control both the beginning year and the ending year. All right, fifth and final hint. I suggest you add a new page to your report specifically for this exercise instead of working on the existing page that we've already built. To do that, you could create a new blank page and just copy and paste from the original overview page, but I recommend that you duplicate the overview page and then remove all of the objects except your table visual and slicer. There is a feature in Power BI Desktop that allows you to duplicate an existing page in your report, so try to find out how to do that. It can save you a lot of time, especially when you've applied specific formatting and styles that you want to carry over between multiple pages. As an added challenge, I want you to try to add a dynamic title to your table visual using the same methods that we used in our video about tooltip pages. See if you can create a title that says population growth by state from X to Y, where X is the beginning year of your analysis and Y is the ending year. Okay, that's enough hints. Begin the exercise and good luck with the quiz questions. Welcome back. Hopefully that final exercise was quick and easy, but don't worry if you struggled with it. Hopefully you learned a great deal from just this one tiny exercise. So let me walk you through how I would have solved this. First, right-click on the overview page and select the duplicate page option. I will rename the duplicated page as Week 1 Final Exercise. Then I'll go through and delete everything on the page except for my slicer and my table. Then I will expand my table a little bit to make it bigger, and I will remove all of the columns except for our state names and abbreviations. Finally, on the slicer, I will remove all columns to make it blank. Now let's begin defining our measures. I'll start by going to the measures table and writing a new measure, which we will call begin population, which will return the population figures for whatever earliest year we choose. I'll write the measure using a calculate function. I will invoke the population measure on line 3, then come down a line, and I'm going to filter using the state's population year and setting that equal to the minimum of the state's population year. Close parenthesis up here, then go down a line, then close parenthesis on the calculate function. And then what I'm going to do to save myself a little bit of time here is I'm going to go ahead and select all of this using Control A and then Control C to copy and commit my new measure. Let's make sure that this new measure is formatted as a whole number that uses commas to separate its thousands. Next, I'm going to create my second measure. I'm going to paste in the formula I just had. I'm going to change the title to end population, and I'm going to change the min function to a max function. This will calculate the latest population figures for whatever latest year we choose. We'll commit it, and once again, make sure that it's formatted as a whole number with commas to separate the thousands. As you can see, these two measures are essentially the exact same, but the begin population measure uses the min function, while the end population measure uses the max function. Also notice how both measures are using the population measure on line 3, which we defined a few videos ago. This is us taking advantage of the fact that measures are reusable in other measures. Now, the final touch. We are going to calculate our third and final measure, which I will name growth rate. This uses the divide function that I mentioned when I introduced this exercise, which consists of 3 parameters that you can see in the small window up on my screen by the formula bar. First, the numerator, which is required, then the denominator, which is also required, and finally the optional parameter that tells our measure what to return if it encounters a situation where it's being asked to divide by 0. In these situations, I pretty much always tell it to just return a 0. So our formula will begin with our numerator, which is the end population minus the begin population, to get the difference between them. Then a comma, then we supply our denominator, which is the begin population measure, and then another comma, and then 0 as the alternate result, and then a close parenthesis. Let's commit it. Then this time let's format this as a percentage, and let's set the number of decimal places after the decimal to 2. All right. Now let's go back to our table and let's plot all 3 of these measures onto our table in order of begin population, then end population, and then finally our growth rate. And now we have this great little sortable table, which allows us to answer a couple of the questions in the quiz about our base period from 1950 to 2015. For instance, we can sort growth rate in descending order, begin population in descending order, and so forth. But we still haven't gotten ourselves the ability to interactively change the time period we're examining. So to do that, we simply need to add the year column from our population table onto our empty slicer, which I will do now. Then we can change the format settings on the slicer by going to the Format panel, then Slicer Settings, and changing the style from drop-down to between. This gives our slicer, when we resize it, a cool little interactive slider that we can move back and forth to change the begin year, like so, and the end year, like so. At this point, we can now begin moving the slider around to answer the various quiz questions that you encountered. Also, to create the dynamic title for our table visual, we simply need to follow the example from our lesson on how to create tooltip pages. We will once again create a new measure, which we will name table title, and we'll just type in some text. We'll say that it should display population growth by state from, then add a little extra space there, come down a line and tab over, ampersand, and we're going to do the min population year. And then we'll do another ampersand, and then inside of quotes, we'll do the word 2. We'll go down another year, and then we'll do max population year, and close parenthesis. So now we can go to our table's format settings, find the title section, expand it, find the FX button to turn on conditional formatting for our title. Then in the format style where it says field value, we're going to change this from first state to table title. Oh no, I added it to the wrong table. Oh, see, it's on my states table. I made a mistake. That's an easy one to fix. Let's go to our data panel, go to table title, change home table from states to measures. Just kidding. Now let's go back to the format settings, and let's go to our table title, hit the conditional formatting button, and then go to our measures table and find table title. Then hit OK. Now our table title displays population growth by state from 1971 to 1998 in my case. It's as simple as that. So that's all you needed to do in order to solve this week's final exercise. Just create 3 measures, add them to your table visual, and then add a slicer that allows you to filter the data by the year from our population table. Then with just a little bit more DAX, you're able to add a dynamic title to the table so that you can go through and, like I'm doing right here, change the parameters of the begin year and the end year, which allows you to see different growth rates for different periods of time. When you're done, just make sure to save your Power BI file if you haven't done so already. I'm going to save mine as, on my desktop, edX-Power BI-week 1, and I'm going to call this US States. And that's the end of our week 1 lessons. In our last couple of videos of the week, we'll interview an experienced Power BI developer to learn how they use Power BI in their work, and then we'll recap everything we accomplished and set the stage for week 2. Okay, everyone, welcome to this special lesson. Today, I'm in our podcast studio here at Davidson College, and I'm talking to Beth Trapp to find out more about her career in data analytics and how she uses Power BI. Beth is an accountant and data analyst with over 15 years of experience in construction, real estate, and advertising. A lifelong learner like myself, she holds a master's in business administration and enjoys continuing her education by taking online courses. In fact, in 2020, she took the very first version of this course on edX. We connected on LinkedIn shortly thereafter and have kept in touch ever since. Prior to her most recent role as a senior construction accountant, Beth also worked as an adjunct instructor, teaching courses focused on college financial literacy and writing style. Her technical experience includes data engineering, data analysis, and report development using SQL, Microsoft Excel, and Power BI. Describing her work, one of her managers said of Beth, "She is highly skilled in data analysis, and her attention to detail is second to none." She was able to take complex data sets and turn them into actionable insights that helped drive our business forward. Her ability to identify patterns and trends in large data sets was truly impressive and helped us make critical business decisions. Beth, thank you so much for joining us today.
Yeah, thank you for having me, Pete.
So I'm hoping you can start by telling us a little bit more about your background, your education and early career, and then maybe talking a bit more about your transition into your later career.
Yeah, definitely. So if you want to start at the beginning, we'll go back to 2007 when I graduated from Arizona State University. And I will admit, like many young people at the time, I had no idea what I wanted to do. It's really tough at that young of an age to be asked to like pick the career for the rest of your life. So I think I kind of convinced my father. I said, if I could just build some momentum and study what I want to study, what I like, something that'll just get me to the finish line. And then I have a 4-year degree. And, you know, a lot of people go on to do things that have nothing to do with their 4-year degree. So the 2 things that interested me most were the Spanish language and art history. So I chose interdisciplinary studies. I combined the 2 disciplines. I studied Spanish and art. I did a capstone internship where I translated for a museum for a little while, just like materials and brochures for them. But it was really just time for me to get working and I didn't know what to do. And fortunately, I lived in Phoenix, Arizona, which at the time happened to be this like hub for-profit online education. Like I'm sure you've heard of University of Phoenix, and the enrollment counselor jobs were aplenty. So I took the first offer that I was given. I became an enrollment counselor, and it was there that I got to working. I loved it. It was so refreshing to work full time and not study full time. I loved working with students. I was enjoying building relationships. I gained a mentor, which became invaluable to me. I have a lot of thanks to give to the man who really brought me into accounting. And it was the CFO at that company that he kind of steered me towards an accounting career. I think he just saw that skill set in me. And when he left that company for a larger university, he kind of brought me with him and helped me get a job in the accounting department there. So I was finally on the path to what was more of a career choice at the time, once I learned how much I loved accounting. And I mean, I vividly remember a business analyst at the university teaching me my first VLOOKUP. And it's not a surprise that that is like a core memory for me, because it just unlocked something. Like it kind of felt like magic, where I'm like, this seems like I'm going down the right path. So that was the earliest portion of my career.
Gotcha. Yeah, it's funny. I kind of remember my same VLOOKUP moment the first time I did one in Excel, and I was like, wow, you can really do some awesome
Yeah,
stuff in Excel. And it
yeah,
just that started the progression towards falling in love with working with data. And same as you, I mean, I came from a humanities background. My degree was in political science.
mhm,
And so there was definitely the first few years of my career didn't really have a whole lot of traction, but once I got working in data, fell in love with it, never looked back. So did accounting then sort of act as a natural progression into working in data analysis for you?
that was well said. That's exactly how it was. So I was working in an accounting department for a university for 4 years, and then for an advertising agency for 4 years. Um, Part of what I was doing was, gauging metrics, like creating performance metrics for accounts receivable issues. Were we solving these things on time for the students and for the staff? But another part of it was just account reconciliations. And so what ended up happening was that I was intuitively cleaning and transforming data. I wouldn't have called it that at the time. I didn't know that's what it was. I was just using my best judgment to say, well, I have these two massive files, things aren't matching, money's missing, and just ended up transforming these fields in a way that I could perform lookups and pivot tables, and I mean, even almost like subqueries, like several pivot tables, so that I could be getting calculated columns for what I needed to find what was missing. And it is funny that looking back, that was going to morph into something much more important in my life. But at the time, I just thought, hey, Excel's really cool, and I like that I can do this stuff.
Yeah, I understand completely. So how did you discover Power BI then?
So I discovered Power BI when I moved from Arizona to the Carolinas in 2018. And much like my younger self, I thought, I've just got to get moving. I've just got to get a job. I don't care what it is. Right. Um, and I think that I just wanted to build some momentum. I accepted the first offer that was given to me, and it was an accounting job at a construction company, which again was just luck of the draw. I love the construction industry. I'm so lucky I fell into it. But there was a CFO there who became a mentor to me. And his wife worked for a data analytics department for a very large corporation. And so when he kind of pulled me aside and said, you're my data analyst now, like whatever this accounting admin stuff is, like you're going to do this stuff for me. I think he saw something in me. He appreciated my work. He knew I had the accounting Excel skill set to support him. So he was the one that said, hey, my wife is talking about this Power BI thing. I think we should try it. And it was a great, really informal way for both of us to kind of jump into learning Power BI. And he gave me a lot of freedom to just try things and kick things around. And that was like probably one of the most fun years of my career.
Gotcha. So you took our course in 2020. So it sounds like you actually already had some experience with Power BI before you even got to us. Is that right?
I think barely. I mean, I knew some PowerQuery. Obviously I knew Excel, but in the time it took for me to start working at this job and get promoted to a position where I was given the freedom to do more of the work I was interested in, it did take about 2 years. So 2020 was when I took that course, and it was at the suggestion of the CFO. He told me, go find one, find whatever you want. Like, we'll pay for a certificate, we'll fund it, you train, and then you learn and come back to us and teach us. And so that's exactly how it went. I admit I always get really excited about these things, and I totally put the cart before the horse. And I was like trying to build things when I had watched like 10 minutes of one of your videos. I'm like, we've got this. But it was very evident that I needed a course to really teach me how to do some of these things.
Gotcha. Understand. So how did that decision to take the course and complete it, get the certificate from edX, how did that impact your career? I mean, did that lead to a promotion or a pay raise, or just kind of like a pat on the back and good for you? Like, what was kind of the end result of that, do you think?
Right. I think in the immediate moment, it was part of the deal of my promotion, right? Being promoted to data analyst. But as far as impact, I mean, I was able to bring value to that organization immediately with Power BI. It was unreal. And I do think that we were overexcited because in the construction industry, we're a little bit behind on technology. I think that's kind of a well-known thing, is that it's just taken us a little bit longer to get there. But so being able to do even just some like ad hoc data viz for my CFO when he's giving me a flat file that he's like, this just looks boring and I'm not going to the board or the meeting with this. And we're able to create something in a couple of days, and we're just both like giddy at our desks, like, oh, this is so much fun. It's so cool. It looks great. Don't we look so smart? It was just really exciting right away, right off the bat. So I think we were thrilled, and certainly I was hooked.
That's awesome. Yeah, I remember doing pitch decks for, not pitch decks, but board decks for board of directors at a company I used to work at. And, we used to just use PowerPoint with static graphs. But, nowadays with Power BI, you can embed Power BI directly in a PowerPoint. It's super interactive and all this stuff. It's an amazing tool. So I know that you've worked with other tools, Excel, SQL databases, and another product called Toric. So how would you compare Power BI to those other tools that you've used?
So I think the skill set is similar for all of them. Like learning one tool helped me learn another. So in the same way that working with Excel helped me learn Power BI, knowing Power BI made it really exciting to learn Toric. Toric is cool because it's no code. They have a whole data analytics workspace where it is end to end, but different people use it for different things. And so they're using transformation nodes, but it still was seamless because you were doing the same actions, like there's an action you can take in Excel, you can take it in Power BI, you can take it in Toric. So that was fun for me to kind of make that transition. And also working with Toric for a little while, I was able to help them, on product roadmap calls when they're like, well, what if we did this? Well, how do other softwares do this? And I was able to bring my Power BI knowledge to that conversation, which was a huge learning experience for me. And then it was interesting that you could even hear when we're talking about different tools, in a group, that you can hear by the way the words that somebody is using, that it's like, oh, you're kind of talking about it from a SQL perspective. I'm kind of talking about it from a Power BI perspective. This person's just talking about it from a sales perspective, so there's all these different things. But SQL, I will admit, I was scared. I put it off. I did not want to learn SQL for some reason. I like, this is going to be hard for me. And after learning those other tools and I started learning SQL, I'm like, why was I, I was writing queries like on day one, and almost like learning a language when all those other tools and you have the skills. It's like I could read it right away. It wasn't. So I feel silly for kind of putting that off for so long, but that was my most recent tool that I learned was SQL, and working with Microsoft SQL Server and MySQL and some Postgres.
That's great. Yeah, actually, in this latest version of the course that we're developing, week 3 of the course, you install a SQL Server data warehouse on your machine and you connect to it from Power BI. So we're actually, ramping that up a little bit so that users can get some real hands-on experience with a real database in the course along with Power BI. So
That's
I think
fantastic. Yeah.
I hope that'll be useful to people. And I'll take this opportunity to plug for our learners the fact that I do teach a course on SQL on edX called Introduction to SQL, where we'll use Postgres databases. So I want to talk now about kind of your experience as a data analyst, and what does a day in the life of a data analyst look like for you? And I know that like the answer is totally different depending on what industry you work in, what company you work for, but your own personal experience. What would you say a day in the life has looked like for you?
Yes, so I'm happy to answer that. It definitely is 2 different experiences for me, only because I've been a data analyst for a software company working remote from home. And then I've been a data analyst working in-house for a mid-sized corporation. But meshing the 2 together, I'll say the first thing, as silly as it is, I always have a lot of coffee and breakfast, because you're going to get sucked into your work and you're going to forget to eat and you're going to get really excited and really involved. And I swear that is like my typical day in the beginning. I want to make sure that I'm like ready for the day, because I'm going to be meeting with a lot of people. I'm going to be solving difficult problems. I'm going to be getting frustrated when I'm troubleshooting an error. And, one day I'll write a book called Eat Breakfast, Get Promoted, right? Like, so that our blood sugar doesn't ruin our careers. But that's very important. And then the first thing I do in the morning is I want to make sure everything's running smoothly. So there are a lot of times where I was ingesting data where I had automations running overnight. And, these were set to run every night. And that would be the first thing I'm checking. Like, is data flowing as it's intended? Like, I want to make sure everything's being ingested and there are no errors. Sometimes in my in-office job, that applied to even just like flat files that have been updated, where, I'm refreshing and just making sure that nothing's wonky, everything works, that my dashboard didn't break overnight. I do sometimes have bad dreams about things breaking, which I'm sure you can relate to.
Oh, yeah.
Yeah. But other than that, depending on where I am in a project, it is a lot of data cleaning and transformation. It is a lot of making those connections, like building a relational model and making sure that I have everything correct as far as like what relates, primary keys, foreign keys, what data set am I using? What do I need to learn in Power BI today that I have to Google because I have no idea how to do it? I Google and a lot of questions. And now, with Chat GPT, there's like a whole different world there of, we won't get started on that, but there's a lot out there of resources and community resources to help you with problems. When I'm not getting sucked into those kinds of things, I'm meeting with people. So a lot of what I do to develop dashboards or reports is meet with leadership, C-level, managers, clients, stakeholders, just starting the conversation, right? Let's talk about what you need. What problem are you trying to solve? What data do we have? Where are the gaps? What can we do with it? And then starting to build something where you're incrementally kind of showcasing your progress and saying, here's what works, here's what doesn't, what do you like, what do you need? And just, gradually building something that works for them. So meetings is a lot of what I did, especially when I was in-house working. A lot of times it was even informal, where you would have something going in Power BI. And really it was like, hey, you come into my office, we need to look at this. Like, what were you talking about when you asked me for, and we're just like pointing at screens. It was very informal. It wasn't like presentations. And, sometimes there was disagreement. Sometimes I had to kind of like finesse and gain buy-in from people that maybe we weren't all on the same page, but it's amazing fun to spend that time putting everything together and then have a finished product.
Yeah, I think there's a conception among maybe folks who might be more familiar with traditional software development that you get a set of very well-defined functional requirements from a business analyst. That business analyst has been talking to the business users. They do all of the interaction with the customer or whoever's making the request, and then you just kind of take those requirements and disappear into your data cave, and you don't have to interact with anyone. And maybe that's how it was in the 1990s. Maybe that's how it was in the movie Office Space, where Spakowski's he's like, I'm a people person. My job is to take the requirements to the engineers. I was just going to
say that, yeah.
Yeah, the engineers aren't people.
I talk to the customers.
Yeah, engineers aren't good with people. But the truth is, with a tool like Power BI, and in sort of the modern paradigm of agile software development, it's much more common and expected for Power BI developers and analysts to have face-to-face frequent interactions with customers and stakeholders. And so, like me, you've got a background in the humanities, but you're a technologist. How do you think that your degree, your education in Spanish language and literature and humanities in general benefited you as a technologist?
So there are two theories I have, and of course I don't have any science to back this up, but the first is, I think learning Spanish and loving Spanish and being somebody who still studies it, something about language, I do think it probably created neural pathways that made it easier for me to learn things like SQL and Excel. And because it's patterns, right? I mean, in Spanish, you're learning verbs and how to conjugate them differently and sentence structure, and you're kind of memorizing these patterns. And I do think that that has helped me. As far as working with art and having kind of an eye for design and, like wishing I could be an artist, maybe those are my retirement years. But for dashboarding, I am confident that I have made some really beautiful things that have garnered attention for being unlike what other people have seen from a data analyst. In that sense, my next move in life may be leaning more into like data visualization, that maybe that is something that I want to look more into, because I have such an appreciation for when things are beautiful and clearly communicated and symmetrical and your eye is drawn to the right thing. And that has been really important to me as well. So I do think I have the left brain, right brain mix going for me. And of course, that also helps me with soft skills. Like I feel like I do have the soft skills to work with people every day and solve problems and things like that. So it's been an interesting path, but I certainly wouldn't change it. My liberal arts degree is, I think, something that still set me on the right course, as it turns out.
Yeah, I feel very much the same way. And you'll be interested to know that this time around in the next version of the course, we're spending a little bit more time on some of those graphic design things, like talking about the visual hierarchy in report design and how to use like things like white space, empty white space to draw your user's eyes to something. So we've got like a whole couple of lessons on that in week 4. And so it's good to hear that you kind of echo, like, I mean, there is a very aesthetic aspect to good Power BI design. Like it's not enough to just put charts on a page and just leave it at that. You really need to pay attention to form as well as function. Form and function go together. So it's great to hear you say that.
Yeah, absolutely. And I think in addition to that, even before design, you hear C-level leadership say, hey, if I look at this thing for 30 seconds and I don't know what's going on, it's wrong. Like this needs to also be like simple. And you need to be able to bring somebody in here and look at this dashboard and they can see what you're trying to say. And a lot of what we're doing is maybe too busy, or we're not taking the time later on the front end to kind of tweak things and make it look nice. I recently read the book Storytelling with Data. And I'm pretty sure I'm embarrassed of everything I've ever created after reading that book. Like I was just like, what have I been doing with grid lines? So there's a lot to learn. And it's great that then your students will know in the beginning some of those kind of foundations.
Yeah. Cole's book is really good. There's a week 4 video where I mention it. And another book, if you haven't read it, do you know who Alberto Cairo is?
Mm-mm.
No. He's a data journalist is what he calls himself. He actually spoke here at Davidson a few years ago, but he's got a book. Well, he's got a few books, but the book of his that I have is called The Functional Art. And it's about data journalism and how to create effective data visualizations that, tell a story. And it's very similar, I think, to Cole's book, Storytelling with Data. And so highly recommend it.
Yeah, I'll check that one out.
Yeah, absolutely. So last question, what do you enjoy the most about your work as a data analyst?
I enjoy problem solving. I enjoy just being a helper. I think that's what makes me happy. That's who I am by nature. So offering any kind of technical solutions, troubleshooting an error and finding the fix when we're all freaking out that something is broken. I love fixing things. And I mean, even just like I said, the aesthetic side of things, I like making things beautiful. I want a dashboard to be pleasing to the person using it. I think that that's something that just became important to me. And really part of what I like about this just day-to-day data cleaning and then transforming and then building the dashboard is I've always liked puzzles. It reminds me almost of a jigsaw puzzle, that it's like, it's a big feat. And you dump it out on your table and you're like, this is going to take me 5 weeks to finish. and we're never going to do it. But then piece by piece, it starts coming together. And then, you have 1 or 2 nights where you start making progress and you're like, ooh, I'm going to stay up till midnight and really make progress. And there are those moments in data where it's like, I think we manically overwork sometimes and we get excited and you're seeing, like, you're gaining that momentum, you're seeing the progress. And then it finally all comes together and you're like, wow, that was great. That was not as hard as I thought it would be. That was didn't take as long as I thought it would. And then you have a finished product, which is rewarding. But something that I also enjoy is that the work never stops. So you don't have a dashboard that's just complete and perfect. I mean, if you have a dashboard that everyone's happy with, they're not using it. Like I feel like people should always be asking questions, like putting a stick in the spokes, giving you a wish list of what they want next. So it's like always evolving and the work is kind of never done.
Yeah, the perfect Power BI project does not exist.
Does not exist.
It's always a living product, and you have to stay committed to maintaining it and keeping that dialogue open with your stakeholders to make sure that it's improving and getting used. And so,
absolutely.
Well, thanks very much, Beth. I think this was fantastic. I'm really glad to get a chance to talk with you, hear a little bit more about kind of how you got into the world of Power BI and how you've enjoyed your career as a data analyst. I love hearing that enthusiasm, that appetite for problem solving and just working with cool technology. That's what it's all about. That's what it's all about for me, at least. And I think that everything that you've said here ought to resonate with, all of our students, especially those who maybe don't come from a technology background and are thinking about making a career change. Maybe they come from accounting, or maybe they come from somewhere else like me. I used to work at, a law firm, so I think that they'd probably love to hear your perspective.
Thanks, Pete.
All right, let's recap everything that we accomplished with our first week of instruction. We'll do a recap discussion at the end of every week in which we will go over the highlights of what we learned, as well as preview the things that we'll learn in the following week. In week 1, we installed Power BI Desktop and introduced you to its layout and some of its functionality, including the PowerQuery editor. And we used these to connect to our first data source, perform some basic data transformations, and load the data into a Power BI dataset. From there, we introduced the DAX formula language and used it to create calculated columns and measures, and we modeled relationships that spanned multiple data sources. We also introduced concepts such as granularity and cardinality, which we can use to describe the level of detail in our data tables and how different tables can relate to each other. And we used all these topics to begin reinforcing specific best practices that we should use in Power BI, such as when to use measures or calculated columns, and why we should always try to use explicit measures with DAX rather than implicit measures. And throughout all of that, we repeatedly demonstrated how to create interactive data visualizations that allow us to explore our dataset to answer specific questions, as well as to find interesting stories that might be hidden in the data. I know that this first report was very narrow in scope, focused just on data from the United States, but I like using it because it's clean and simple, and it's perfect for illustrating all of these concepts to learners who are just beginning their Power BI journey. At the same time, it can be made more complex by simply adding on more data, like our population figures, a fact which in turn allowed us to introduce more ideas around data modeling and visualization. In next week's lessons, our viewpoint will expand outward to become more global. The data we work with will be structured in a similar fashion to the U.S. states data that we used this week, but we'll be looking at economic data from countries across the world, and we'll use this to dig deeper into data modeling topics with an enhanced focus on DAX and table relationships. Okay, everyone, thanks for finishing week 1 of our course, and we'll see you in week 2.